morning, everyone. The guest speaker has not joined yet because of some network issue. We'll start the session after 5 to 7 minutes.
Yeah. Good morning, madam.
Thank you.
Hello, madam.
Hello.
Madam, have you connected?
Is it T. Kishore Kumar, sir?
Yes. Connected, madam. Hello. Is my voice audible, madam?
Yes, sir. Yes, sir. Your voice is audible.
Yeah, I joined, madam. I joined.
Okay, sir.
You please start, madam. There is some internet problem. That's why I could not join.
Okay.
Is it Dr. Mamta, madam, is there?
Yes, Mamta ma'am is there.
Yeah, you just inform, madam, actually. She is trying, actually.
Yeah, sure. So myself, Veena Gowde, Assistant Professor from Electronics and Telecommunication Department, AP Shah Institute of Technology, Thane, gives a warm welcome to all participants and guest speaker for the 4th day of AICT ATAL sponsored Faculty Development Program on IoT, a journey from sensor to server. Yesterday, we enjoyed expert talks about communication interfaces for IoT. Today, we are moving for the next milestone of this learning journey of IoT. On behalf of APSIT Thane, I take this privilege to introduce first speaker of the day, Dr. T. Kishore Kumar. Dr. T. Kishore Kumar is Professor, Department of Electronics and Communication Engineering, NIT Warangal. Received his BTech in Electronics and Communication Engineering from Sri Venkateswara University and MTech in Digital Systems and Computer Electronics from Jawaharlal Nehru Technological University. He obtained PhD degree in the area of signal processing in the year 2004. With his unflinching commitment and ardent passion toward teaching, Dr. T. Kishore Kumar headed the Department of Electronics and Communication Engineering, NIT Warangal, during 2015 to 2017. Currently, he is a professor at Department of EC, NIT Warangal. He was the head of the Institute Computer Center from 2018 to 2020. He was the visiting professor for Asian Institute of Technology, Bangkok during August to December 2019 under secondment of Indian faculty by MHRD, Government of India. He is also member of Andhra Pradesh State Council of Higher Education. He was awarded Research Excellence Award 2017 by Institute for exploring advances in engineering for his research work. Dr. T. Kishore Kumar has contributed substantially to the qualitative research endeavors in the department. His current areas of research include signal processing and speech processing. He has completed 2 DRDO projects worth 18 lakhs and 1 MHRD NEMICT pedagogy project worth 7 lakhs. To add another feather in his cap, he has the credit of receiving 2 major research projects sponsored by SERB worth 41.92 lakhs. Besides this, he has also 2 SERB projects worth 47 and 25 lakhs as a co-investigator. He has published 36 international journals and 39 international conferences during the last 5 years. He has organized several faculty development programs in the domains of signal processing, speech processing, real-time embedded systems at NIT Warangal and outside. He has delivered several guest lectures at DRDO, ECIL, JNTUH, and other institutes of repute in Andhra Pradesh, Telangana, and Maharashtra. He is a member for Board of Studies in NIT Warangal, Kakatiya University, JNTU, Hyderabad, and SV University. He is also a PhD examiner for NITs and several other universities across the country. Now I invite Dr. T. Kishore Kumar to give a talk on the topic of data storage or representation and dashboard design. Over to you, sir.
Okay, madam. Thank you very much, madam, for your brief introduction about me. First of all, I'd like to thank the organizers of this particular program for inviting me to deliver talk on data storage and representation. Personally, I would like to thank Dr. Mamta madam And I also apologize for a bit late because of some technical delay. Okay, so now I will try to share my PPT, then we will proceed our talk. And my talk, there are two parts that I will try to discuss today. The first part is about the Internet of Things, how it is used, and the second part is dashboard. And afterwards 15-20 minutes we can have purely interaction session. We can discuss and we can share our experiences, because I heard that all the faculty who come from other parts of the country. So with these few remarks, once again I would like to congratulate, and I will start my session. I will try to share. Is it visible, madam?
Yes, sir, it is visible.
Now?
Yes, yes.
Okay. So I hope that all the participants are faculty from various institution departments. Is it right?
Yes, sir.
Okay. So today my topic is the IoT data storage and representation and dashboard design. And basically the another part is dashboard for IoT applications. So before that, just we will try to discuss about, as I told you that the IoT, what is the Internet of Things? So basically, the Internet of Things is the network of physical objects or things embedded with electronics, software, sensors, and network connectivity, which enables these objects to collect and exchange data. So from the physical objects or physical things, we will try to collect the data, and we will try to exchange this particular data by interconnecting the different types of the things, or what we can say devices, and which allows the objects to be sensed and controlled by remotely. We can control across the existing network infrastructure, and we can create the opportunities for more direct integration between the physical world and computer based systems, and resulting in the efficiency, accuracy, and dynamic benefit. Madam, that screen is coming. Can you? I think in PPT that is okay.
Yes, PPT is visible, sir.
Yeah, that is visible, but
Yes.
right side, just
IoT slide is there. IoT, Internet of Things. The basic definition.
no. Okay.
Yeah.
So, which is used to resulting improved efficiency, accuracy, and economic benefit. Now, coming to the basic fundamental definition of the Internet of Things. Everybody, they might have the idea about the Internet of Things, but from the Wikipedia, the definition of the Internet of Things is the Internet of the objects, which refers to a wireless network between the objects. Usually, the network will be wireless and self-configuring, such as the household applicants. This is one type of a definition that we can obtain from the Wikipedia, and most of the time we can feel that, or we can observe that such type of what we can say the phenomena that we are observing when you talk about the Internet of Things. That means we need to connect the world, the physical thing, to the electronic things or the sensor thing, and ultimately we can get an outcome which will give a what we can say the fruitful outcome, which is useful for the society. The second definition, the latest one, is in 2020. The Internet of Things, which are having the identities and virtual personalities, operating in smart spaces using the intelligent interfaces to connect and communicate within the social, environmental, and user context. So these are the two definitions that you observe here. So somehow what we are doing is we are trying to connect the physical world with the electronic devices or different what we can say smart devices.
एसी नहीं लगाया सर? एसी
Coming to
एसी
the
चालू है, थोड़ा टाइम के बाद हो जाएगा.
Internet of Things means now you can see that from any time, from any place connectivity for anyone who will now have connectivity for anything. So you can see this the representation, anytime connection, any place connection, and anything connection. And from this is a what we can say a three-dimensional axis. On the move, the outdoors, indoors, night and daytime, we can connect anytime. And any place connection means on the move, in the case of the outdoors, the away from the PC personal computer, and at the PC itself we can have the connection. And anything connection means between the PCs, human to human, not using a PC, human to thing, using generic equipment and thing to thing. So why I am showing this particular thing is the Internet of Things, as I said, the connection of physical world with the different smart devices at any particular time or at in any particular place or any particular connection, we can integrate all these things and ultimately we can develop a particular product which will use as a smart device. So that is called the Internet of Things. And if you see the technology roadmap of IoT, the technology roadmap, if you see the technology reach versus the time, in the year 2000 to 2020, the supply chain help us if you see the initially the RFID tags for facilitating routing, inventory, and loss prevention. We can use this, and then slowly the technology is increasing for surveillance, security, healthcare, transport, food safety, document management. We can use and locating people and everyday objects, and from there the teleoperation and tele presence ability to monitor and control distance objects. So you can see that the supply chain help us vertical market applications and ubiquitous positioning, and then physical world web. So this is the actually the technology roadmap for the Internet of Things. The stage by stage, as the years progress, we can observe that the development of this particular technology. So this is actually the importance that we are observing. And even in the corona time now, the what you can say, the more emphasis, the more importance people are giving to this particular IoT, machine learning, artificial intelligence, such type of cutting edge technologies, people are giving this particular the importance. Earlier days we have the machine learning, artificial intelligence, but we are not very much impressive about those things. But as the days goes on, as the crisis comes, now we are seeing that the usage of this particular the what you can say the smart technologies which we are using. So this is about the technology roadmap of IoT. And coming to the IoT device usage, you can see that there are different types of devices which we can use it for IoT usage. The acceleration of IoT domain was due to the following advancements. So earlier days, we can have, as you see that the IoT acceleration, which we can, the acceleration in the sense that we can advance the particular IoT by incorporating the sophisticated environments to that particular IoT. When you are connecting the physical, the world with respect to the electronic devices, so the smart devices, the advanced devices, when you connect, we can improve the accuracy, we can improve the speed, or we can get the outcome very fast. Okay, so here see the microcontroller. Earlier days people use the microprocessor. Now we can use the microcontroller which is used for the price and performance, a key role it will play. Then wireless connectivity pricing, as we are seeing that after the geo enters into the world, so we can observe that everywhere they are conquering, such that we can in a very affordable price, which we are getting that particular connection. So the wireless connectivity, which will improve the acceleration of the particular IoT, the sensor advancements, various sensors has come into picture in order to connect the physical objects, and to with the help of these particular advancement sensors, we can achieve the major outcome. Then cloud-based software and infrastructure, this is also vital, the role it will play in IoT acceleration, then application development. So you can see the IoT device usage rate is the now the it is the 50 billion. So earlier the world population is 66.3 billion. The connected devices are 500 million. Now when 6.8 billion people, 12.5 billion. Now 7.2 billion people, 25 billion the devices they are using. And 2020, the 7.6 billion people, they are using the connected devices. So this is the the IoT device usage rate as the figure. Then if you for real-time embedded systems in Estonia, when I got down, the people used to say that that country Estonia, it's a very small country, but they say that that country is a digital country. So entire the as soon as I got down from the airport, everywhere in the outside or wherever you can go, the internet is completely free. And here in India, so still we are observing that we are facing some problems in institutions or some other places. The connectivity problems are different types of the usage of the smart technology. Still the Indians, they are trying to get the awareness, and then slowly they are improving. But there, the before 5 years or 10 years itself, they are using this particular technology. So that's why a small country, it's like we cannot think about Bombay, but that type of area, they're calling that particular country itself as a digital country, Estonia. So why I'm the emphasizing that the IoT, it is dominating the technology which dominates the particular the present scenario. Now you see that 2003, 2011, and 2020. So the humans are 7.6 billions, and the devices which they are using for the connectivity is the 50 billion devices. They are interconnecting with the physical objects. So this is the usage rate as just now how what I discussed, the human versus the internet connections. Now, why the Internet of Things? Why do you want to go for Internet of Things? Thing is the dynamic control of industry and daily life. The dynamic control of industry and daily life. The second one is we can improve the resource utilization ratio, the better relationship between the human and nature, forming an intellectual entity by integrating the human society and physical systems, and universal transport and internet working, accessibility and usability, and access technologies integrator. So these are the why do you want to go for Internet of Things means, one must remember that in order to have the dynamic control of industry and the daily life. So we can see the industry, there are certain the industries which are completely controlled by the remotely. People can control the particular industry. In such cases, the IoT plays an important role even in our daily life also. The second one is we can improve the resource utilization ratio. Just now we have seen that when 7.6 billion people, they are using the 50 billion devices. That means how much the utilization of these particular devices, which are used for connection of different types of physical objects. That means the utilization ratio is, as the days goes on, as the technology advances, people are utilizing the device number of devices will be more, so that what is happening is, so we can improve our the accuracy, we can improve the speed, and in turn, within a less time we can reach our goal. So you can see the earlier days we have a manual train, now we have a bullet train has come into picture. So completely, what you can say, automatic electric trains that are coming. Why we are using such type of the trains? The speed, so 500 kilometers per hour the trains are moving. That means the speed we can improve, we can improve the accuracy, then better relationship between human and nature. So we can, as I said, the connectivity, the integration of the human versus the nature. So how best we can use the different types of the physical objects with the internet connection, and we can have the better relationship between the human nature and intellectual entity by integrating the human society and physical systems. And then we can have the universal transport and internet working, and accessibility, usability, as we have seen that, acts as a technology integrator. So these are the things that are very much essential to know why we are going for the Internet of Things. So coming to the business perspective, usage rate of IoT, just now we have seen that the day-to-day life, how people are using. Still I will try to give some examples, but here when it comes to the business perspective, usage rate of IoT is the driver of all this connectivity is essentially the desire to add value to products or services. That is the first thing. We need to add the value to a product, that is quality. Then now you can see that the $100 handset turns into $1,000 smart device connected to internet. So that is the actually the what you can say, the adding the value to the services. So simply $100 handset, which turns to a $600 a smart device when it connected to a internet. So that type of the adding the value to a particular device. So the additional profit is in the market 50% of the potential of the using internet which we are using. So as a whole, I can say that this particular IoT as a network of networks, as a network of networks. What type of the networks that we can use with respect to the IoT? Number one is the individual networks which are connected together with security, analytics, and the management. So individual networks means we can say the transport, energy, business, education, home, earth, all these things which we will connect together for achieving the high security, and we can do analytics and management. These networks connected with added security, analytics, and management capabilities, which will allow IoT to become even more powerful in what it can help people to achieve. So this is actually we can call it as a the Internet of Things as a network of networks. So network of networks means here it's a the as I told, the physical world which is connected to a smart devices. So here the physical world or a physical device or a physical thing is nothing but the transport when you take the transport. So in the transport, so even you can see that one example I will tell in abroad actually now, here also slowly it will come. So in abroad, the by using the GPS, so we can track the status of that particular vehicle. So they connected this particular the bus, the travel. They are enabled this particular bus with the smartphone device. Even now also, we have a private travels are there. So in the private travels, the bus, we can track the status of that particular bus, where that particular bus is there, at what time it will come. That means the transport department, they are using this particular Internet of Things. That means a physical device they are connecting to with the help of the sensors. They are connecting to the another particular sensor, and they will try to know where the particular the vehicle is there. And similarly, other particular things like a speed post, when I do some particular speed post, so now with the help of that particular the PNR number or whatever the EN number, they will give that particular number. With the help of that particular number, I can know the status of that particular item. And even in the Amazon, in our mobile, when you download that particular Amazon profile, so app, now once if you book the particular any particular item, automatically we can know that where is the status of that particular thing. You can see that it is on the way. So now where it reaches, so suppose from Hyderabad, if I transport any particular the item to Delhi, then it will indicate that now next it reaches the Madras, and then afterwards it reaches the Bangalore, and then it enters into the Delhi, and then from the particular market to it is going to a particular place. So that means how do I can achieve all these things? There the IoT plays an important role. So a network of network, the transport, just I am giving an example. Similarly, energy. So we can find out the energy. So how much energy does it require for a particular the house, and in turn, how much energy that is required for a particular the street, and how much energy that is required for a particular the district and state and country. So how we can adjust the load, and how we can they supply the particular load, all sort of things that we can observe with the help of the IoT, that is called the network of networks. The business, so we can in the share market earlier days, we can calculate manually. People will calculate and they can know the when the share price increases or when the share price decreases. Now the people nowadays, I think every YouTube individually during this particular corona, people use the you can they are preparing the YouTubes and they are uploading. And during that particular, when you are watching the particular YouTube, they will tell the Bino app or some other the financial app, they will tell. And they are telling that you need not you need not worry about the particular money. So then once if you buy something, and if you see the particular graph, and automatically when the graph is increasing, you can sell your particular share. So then immediately you can get a gain. And I think most of the people these days hearing about the crypto coin. So even in the crypto coin, this is the same thing. They have a particular the AI algorithm is there, and it will calculate and it will give the automatically the increasing that particular value, it will automatically, it will multiply, and it will when it has to sell or when it has to buy, all these things in your app only it will detect, and it will give the particular result, and then automatically you can gain the money. So that is the actually, even in parliament also, people, there is no authorized legalship is there, but still people are earning money with the help of crypto coin. So how we are achieving these things? It is again the network of network, the usage, the IoT as a network of network which we are using. And for home applicants we can use it. And in the education, now you can see the how we are listening your lecture online, and there is actually gadgets, so we can interconnect. And the a lot of the IoT enabled devices which we are using, there is a stylus which is there, and I can mark that and I can write that, And we can, what we can say, and even in the after coming to the digital, so the Google Pay has come, then Phone Pay has come. So then different types of the transactions that are coming to picture. So these are the some of the examples that everybody familiar with this particular thing. So that means I can say that this particular IoT as a network of as a network of networks. So how the particular IoT works? So the Internet of Things is not the result of a single novel technology. Instead, the several complementary technical developments provide capabilities that taken together help to bridge the gap between the virtual and physical world. These capabilities include the communication and cooperation, addressability, identification, sensing, actuation, embedded information processing, localization, user interfaces. So these are the stages how this particular IoT works. Communication and cooperation. That is first thing. As we have seen that we need to communicate each device and they should cooperate. That is integration is very, very important. Addressability, then identification. So location of that particular address we need to they identify. Then we need to sense the particular any particular the information, or if you want to get the data by sensing a particular thing, then we need to have a particular sensing. Then embedded informing the information process. So this embedded information processing is, so we need to embed the information in order to have a particular control, or in order to get a particular data, we can use the embedded information processing, then localization and user interface. So these are the things that which are useful when you take the particular IoT. Now the few applications of IoT is, number one is building and home automation. So as we have seen that building and home automation, then manufacturing, in manufacturing people use, then medical and healthcare systems, lot of the advantage that we are observing in the case of medical and healthcare system, then media, environmental monitoring, infrastructure management, energy management, transportation, better quality of life for elderly. Okay, so can anybody give me some examples about the as I have shown the applications? Any of the participants, how we can come across the building and home automation? One example, can anybody tell from these things? General, just now I told, na, how we are observing the application of IoT in these things. Is my voice audible?
Yes, sir.
Yeah. So any participant, whether you have to give permission, madam, for them to speak.
Yes, participants, you can unmute yourself and talk. Already they have posted some answers in the chat box as well.
Yeah, sure. Good,
Like
good.
Alexa, smart home.
Yeah, yes, exactly. So anybody, so any novel thing just now by observing these things?
One more answer, HVAC.
Okay, good. So is it understandable? Are you following my talk?
Yes, sir. Yes.
Yeah. So these are the applications of IoT in various domains. Now coming to the, sorry, coming to the what we can say, the, madam, that on the top of the slide it is giving that bar, you can remove that.
IoT life cycle.
Okay. So in the, when you see the IoT life cycle, okay. So there are different stages will be there. Okay, number one is the process of conception to product is known as product development cycle. The first stage is the product development cycle. You just remember, excuse me, the product development uh, life cycle. The second one is an IoT solution development cycle consists of both software and hardware development. So that is the second point. So everybody should remember the IoT life cycle means the first one is the process of conception to product. Conception to product means the particular the person the customer, they have some particular idea. They will ask the vendor, for my particular the domain I need some particular product. So he will throw some particular goals, and from these particular goals what we need to do is we need to develop an idea, and from the particular idea we need to develop the product. And for this particular product there is a development cycle. So for this particular development life cycle there are certain stages, and basically any product which we want to develop according to the idea, naturally it requires the hardware and associated software. So the second stage is the hardware with respect to the software. And the third one is we all are already aware of the software development life cycle, but the hardware part is still not very much clear, because the infrastructure, the still people are going for the traditional hardware we are using, but the sophisticated hardware within the less cost, how best we can use the hardware, which is another important goal. And although the hardware part of IoT solution requires a complete understanding of the product, sensors, firmware, circuit design. Okay, so these are the actually the three things that we need to do. So let's understand the stages involved in the development of an IoT solution. How when you want to develop an IoT solution, what are the stages and how we can proceed? As we have seen, first thing is the idea is converted into a product, and after getting that particular product, then we need to provide the software and associated hardware. Even still, if you provide the hardware, you should have a clear understanding of that particular hardware. Now we will try to see that this is the IoT life cycle. From the description what I said, the inception is important. From the inception means the idea. From the inception we need to design, and after design we need to review the particular the design. So any particular errors or any type of the mistakes that occur, we need to review that. And after reviewing you need to develop the prototype, and after prototype we need to do testing and validation. So these are the stages of IoT lifestyle. You please remember, the first one is the inception, second one is the design, the third one is review, fourth one is the prototype, and the fifth one is the testing and validation. Okay, so you can see this. So we can see that the first step is every project which gets started with understanding and getting of list of price requirements from the particular the problem. We need to realize the possibility. Okay, so the now you try to the think such that a particular customer, he called the vendor and he is sharing that. So discussing the idea with the customer and gathering what he actually wants to achieve with the project, which is the initial step for the development of life cycle. So you need some particular the home automation. Okay, so then for that particular home automation application, you will clearly explain the the what type of the what you can say, what type of the goal that you need to achieve, you have to tell. And the second one is the client is brainstormed with the questions related to the project, considering power, size and size estimates, and a complete document is created for the requirement. And third one is, after understanding the idea and gathering the requirements, we analyze the possibility of the project. Okay, so the functional requirements are given after considering the possibility, and then strategic plan is created for the IoT solution. So these are the steps that are needed for a particular IoT solution if you want to develop the IoT product. But anyhow, as I have shown the IoT life cycle, first we need to do the inception, then from the inception we need to do the design review, and after review again we need to go for the test and validate. So these are the steps that are needed. Now you can see the inception. The first one is the inception. After gathering the data, we need to realize the possibility whether it is possible or not. We need to think. Then the second one is circuit design. A team of engineers starts transforming the idea with the specific technology, software, circuit design, algorithm, and other essential components to build a prototype. And in this step, the right connectivity solution for your IoT product is identified based on go-to-market strategy, and everything from ratio of cost performance with solutions to designers challenges discussed. So the first one is, after getting the idea, we need to design. Then after design, madam, on the title side, the top, there is a screen bar is coming. Can you remove that bar?
Screen bar is not coming, sir. The
Screen
title
bar
is properly visible. Design transformation of the idea into circuit design. Like that.
for me.
So since you are the presenter, for you that bar will be visible.
Yeah. Okay.
So you can scroll it down as well for your convenience.
Okay. Yeah. Correct. Thank you, madam. So now,
Welcome, sir.
yeah, transformation of the idea into circuit design. The third stage is the reviewing the circuit design and the functionality at every particular point. So the throughout the project, there are the schematic, then layout, the software algorithm, and mechanical aspects of the product are reviewed from time to time. So we need to develop a particular product. So for that, every time we need to review. So what type of parts that are needed, how we can develop. Then this is actually a crucial stage. The product's reliability in future depends on reviewing the loopholes and making it feasible to use critical condition. Is it important to review IoT prototype throughout, because it helps improving the manufacturing and performance product, and which also reduces the what you can say, the cost. Then the project review phase not only helps in developing the phase, but also helps in making the product user friendly. So what I mean to say from this particular slide, so the how best we can review the particular the design. Okay, so if there is any possibility to reduce the cost, to improve the accuracy, to improve the speed, it's like a feedback type. Okay, so we can check and correct it, so that we can develop the efficiently. And as I told you that the main goal of the IoT is added value to the service and added value to the quality. So that type of the value for a particular product, which we can increase, which we can incorporate, how best we can review our system. So that is more important. So the idea, then design, then review. So this particular review we can recheck every time. Okay. So functionally at every time we need to review. Then building a product. The prototype of the actual product is built during this particular phase. We can embed the boards, development kits, sensors, simulators, modules are tested with the firmware written. And the process of IoT prototyping and is done several times till the desired prototype is made without any particular error. So this is the actually the IoT prototype, the building a proof of concept. Okay. So we can do the proof of concept. Then coming to the validating, after the IoT prototype, after the IoT prototype, the next step is to test it with various conditions and validate it with its software, application, and server. So validation plays an important role because whether my prototype model is the input when I am giving the corresponding output is correct or not, whether it is the working properly or not, we need to validate it for various the inputs that we need to consider. The second one is the prototype and its application is validated before taking it forward for manufacturing process. And third one is the different parameters of the hardware such as signals, voltages, amplitude, magnitude, temperature, heat conditions, power consumption, etc. are tested. So randomly we can change these particular parameters. Then we can test the particular thing so that whether the corresponding prototype is working properly or not, we need to test. And the final prototype is one which the client approves for manufacturing. So this is the last but one stage. So after testing and validation can be done, so then finally the particular prototype which claims approve for manufacturing. Okay. So testing and validation, this is testing the prototype and validating with the customer. Then coming to the stage is manufacturing, that is fabrication of the printed circuit board and its assembly. Okay, so after manufacturing, we need to fabricate that. So the product prototype is tested over assembly line to make product success. Then the manufacturing of the product can be done for bulk products. The tests such as stress testing, defects identification, individual components testing is performed for the product. And after the issues are identified, the reason for the problem is checked and the rectification of the problem is done. The final prototype is given for manufacturing. So these are the things that we have seen that we need to test. Then fabrication of the printed circuit board and its assembly. So we can do the printed circuit and assembly. So there are actually, this is actually basic blocks for building IoT setup. Now we are seeing the stages. Okay, I think you have an idea about IoT life cycle. So, okay, quickly, can anybody tell me? So, what are the steps involved in the IoT life cycle? Quickly, one person, can you tell me what are the stages? So, just quickly message me that what are the life cycle of IoT stages?
Inception, design, review, then IoT prototype making, and then testing and validating.
Good, good. Can you tell me your good name, madam?
Veena, Veena
Within
Gauthier.
same institute or other institute?
Same institute, sir.
Okay, okay. I expect the other institute people if they are. So
Okay.
please respond. Okay, it's okay. So at least why I'm asking is they because of this online. So at least one-to-one correspondence, if it is there, then the speaker will get interest. Otherwise, simply whether they are listening or not, I don't know. Okay. So some people they will switch on their mobile or laptop and they will do their work. So the that is the punishment for the speaker and organizers. Okay. Now coming to the basic blocks for building IoT setup is now these are the crucial blocks. Any particular IoT. Just now we are seeing the IoT solution. Now the stages. Now we can see the general basic blocks which are very essential for building any IoT setup. Okay. So first one is the radios. So the radios are the chips that provide connectivity based on various radio protocols. The second one is the sensors. Here, the sensors mean the chips that can measure various environmental and electrical variables. Then third one is the microcontrollers, where microcontrollers are the processors or storage that allow low-cost intelligence on chip, and modules are the combine radios, sensors, microcontrollers in a single package. Then platform software, the software that activates the monitors, analyzes device network, and application software means which presents the information in usable, analyzable format for end user. And we can use the device which integrates the modules with the app software, application software into a usable form factor. And airtime is use of licensed or unlicensed spectrum for communications, and the service is deploying or managing supporting the IoT solution. So these are the basic blocks for any particular IoT setup which we can use it. Okay. So of course you may not require all the particular blocks, but some of the group of 3-4 blocks or group of 5-6 blocks put together, we can have a IoT setup. And coming to the IoT application domains, for consumer electronic consumer, the smartphone control, security, optimized energy use maintenance we can use, retail product tracking, inventory control, focused marketing we can use. Then medical, we can have a variable devices, implanted devices, telehealth services. This is very, very important these days. People are using the medical. And one more thing, when people are submitting a project, most probably these days people are saying the government of India how socially it is relevant to the public. Okay, so especially for medical wing, they are giving the more importance. Yesterday, I got one SCRB CRG project sanctioned for the development of knee disorder location. We are developing a IoT enabled based prototype model for worth 45 lakhs. the project which is sanctioned. There, the medical application with the help of IoT, I am developing. Of course, I am using the AI machine learning, the techniques which are using, and whatever the device that we are connecting, we are developing that particular prototype, which is enabled with the help of the IoT devices. What I am doing is I am the gathering the information about the knee disorder, and this information through cloud I am sending through mobile to the doctor, and the doctor, he will get the particular information and suitable treatment he will provide from there itself. So that means patient need not go and approach doctor, but through cloud he can get a mail or SMS or information to the doctor, and doctor will go through and he will send the prescription. So that means this particular IoT application domain, which very the vital role in the case of the medical. Okay, variable device means by keeping that particular variable the watch. Okay, so we will know what is our BP, blood pressure, and how many steps I walked, how many which are needed for a particular day, how much calories it is the burn. So all sort of things which we can get it. So this is also another IoT application. Then military resource association allocation, threat analysis, then troop monitoring. Then in the case of the industrial, smart meters, warehouse sensing, manufacturing control, climate control. Then automotive is packing, then traffic flow, anti theft location. Okay, so then environmental is the species tracking, then weather prediction, resource management, and then agriculture is crop management and soil analysis. So all sort of these particular application domains which are useful in the case of IoT. And coming to the smart shopping using IoT, you can see when entering the doors, scanners will identify the tags on her clothing. Okay. Then second step is when shopping in market, goods will introduce themselves. Automatically, the display will come, and when moving the goods, the reader will tell the staff to put a new one. Okay, automatically it will introduce. When paying the for the goods, the microchip of the credit card will communicate with checkout reader. So all these things which are completely the smart shopping using IoT. Okay, so this is about the IoT. Okay, so this is the first part of the IoT. So I'm giving the 5 minutes time. You just recollect whatever I told, and if any clarifications, you are welcome. Just 3 minutes. Just I will have a water and then I will start. So meanwhile, you just think, and any discussion 5 minutes. I'll give the time for discussion for the part one, the session one, what we discussed. Then afterwards, we'll move to other session. So anyone? So just I had a water, then I came. So now, please interact your. Any doubts or any clarifications? Veena madam, please ask them whether they are hearing my voice or not.
Yes, sir, you are perfectly audible.
Yes, sir, you are audible.
So no participant is not communicating or talking, at least. So first part we have completed about IoT. Okay, how it is useful. We discussed starting from the definition, then applications, the life cycle of IoT. Then we have seen the stages, and if you want to design or develop an IoT solution, what are the devices which are devices which are needed, and various applications which we discussed. Okay. So if no clarification, I'll move to the second part. Is it okay?
Yes, sir.
Yeah. So quickly, I will try to talk about the second part about the dashboard. Now, what is a dashboard? Okay. So a dashboard is a visual display of all your data, whatever the data. Suppose in any particular institute, as soon as you enter a particular institute, so it will give the display. And even simple example, nowadays when you go to railway station or airport, so the display it is coming. So the flight's information, at what time, what is the flight number, and from the what would be the destination, and source and the destination. They will write whether it is a delay or not, and which particular gate that particular boarding is come, and where the particular luggage, the baggage we can, and where we need to do transfer. So all sort of details that we observe in the airport. And in the case of the railway station, so which train at which particular platform, whether it is delay or not. So all sort of things that we will see, there is a display that is coming in front of while going. There is a display screen will be there, LCD display or LED display, some particular display. So that particular display, which consisting of the data, that particular display, what we can call it as a dashboard, which is a visual display of all your data, which is called the dashboard. The primary intention is to provide information at a glance, such as the key performance indicators they will try to give. A dashboard usually sits on its own page and receives the information from a linked database. So they will try to enter the particular data from a system, then automatically in the dashboard it will be displayed. Many cases it is configurable, allowing you the ability to choose which data you want to see, and whether you want to include charts or graphs to visualize the numbers. So a particular person, a team of people will be there, so they will try to transfer the data. So depending upon the usage, or depending upon the understanding capacity of a particular person, they will give the indication. Normally in dashboards we can observe that it is easily we can understand. In every common man can, as soon as if they see the particular dashboard, they can understand that particular data, or they can understand that particular information, and they will follow the work. So that's why in airports it's very easy, even the unknown person also easily they can go and reach the destination. After coming outside the airport it is very difficult, but inside the airport, so which particular gate or which particular the security place or what I need to do, everything it will be clear cut, the indications they will give, display will come, and easily we can do our work. So that is the advantage of this particular dashboard. And also what it is saying is it is a configurable one. So whatever the way which we can keep the particular data, we can incorporate that particular data. Suppose if it is easy to understand with the graph, or if it is easy to understand with the numbers, we can keep automatically the data, whatever we are giving on a particular system, it will come, it will interface to the particular data, the dashboard, and it will display in the LCD screen. That is called the dashboard. So what are the benefits of the dashboard? Benefits of the dashboards. Benefits of the dashboard is the number one is the visual representation of the performance with charts and graphs, ability to identify the trends, easy way of measuring the efficiency, means to generate detailed reports with a single click, the capacity to make more the informed decisions, and then total visibility of the all systems, campaigns and actions, quick identification of data outliers and correlations. So these are the benefits. Then reasons for building IoT dashboards. What is the necessity to build the IoT dashboards? The first thing is the automatically enhance the incoming data from your equipment with the location, time, weather, temperature, and other external factors unique to your customers. That is the foremost the advantage of the particular IoT based dashboard. With the help of IoT dashboard, users and operators can monitor and control specific assets and process from anywhere in the world. The third one is monitor hardware and software performance to reduce the operating costs as well as lower maintenance cost by preempting the product failures and minimizing the downtime. Learn how customers use IoT device at a granular level and let it guide your product development, and quickly bring your own IoT analytics product to market to offer customers premium dashboards and reporting functionally. So these are the rather we can say that these only the benefits or reasons why we are using this particular IoT dashboard. Then thinking aspects during design of the dashboard. When you want to develop a dashboard, so we need to consider all these particular issues. Before building your IoT dashboard, you should ask yourself some important questions. What components should be presented on the dashboard? Where will my data be received and processed? What protocols will I use? Will I build a custom dashboard or use ready-made solutions? What gateways will you use? Why do I even do IoT dashboard? So these are the points that we need to take care while developing the IoT dashboard. Is it okay? So when you want to develop the IoT dashboard, so these are the constraints that we need to take. Are you following? The participants have got an idea about what is a dashboard?
Yes,
Why
sir.
do, why do you want to go for a dashboard? What are the reasons that you need to go for IoT dashboard? Is it okay?
Yes, sir.
Yeah. So while preparing the dashboard, you need to take all these considerations. Now, there are certain considerations to design IoT application and a dashboard. There are three different constraints are there. One is IoT connection types, IoT network types, and IoT protocols. Now I will try to discuss. These are the three main constraints to establish the IoT platform for a dashboard. One is the IoT connection types. What type of IoT connections does it require? Direct connection between two smart devices, data transfer between sensors and gateways, gateway to data system, that is data transfer from gateway to the data cloud, and between data systems. This is another, the IoT connection type. These are the four connection types, IoT connection types, which are useful for dashboard. Then IoT networks types. What are the different types of networks types that are there? The first one is a nano network, a set of small devices sized few micrometers at most, perform very simple tasks such as sensing, computing, storing, and actuation. Such systems are applied in the biometrical, military, and other nanotechnology areas we can use. The first network is a nano network. Second one is the near field communication, where a low speed network to connect electron devices at a distance within a 4 centimeter from each other we will use. Then body network, area network, and personal area network. So that is IoT, the connections, connection types. Then this is the IoT networks type. This is also another constraint. Third one is the IoT network type is broad network works is types is local area network covering the area of one building, campus area network, a network that the unites smaller area network within a university or within a college or within a enterprise, metropolitan area network, a big network for a certain metropolitan area powered by microwave transmission technology. And the fourth one is the wide area network, a network that exists over large scale geographical area, unites different smaller networks including LANs and MANs. So first one is the IoT connection types, next one is the IoT network type, and third one is another one is IoT network type, and third one is the IoT protocols. This is also very important when you are connecting the IoT and dashboard. One is the MQTT, that is message queue telemetry transport, data distribution service, advanced message queuing protocol, and Bluetooth. Okay, so these are the what you can say IoT protocols which are useful while connecting the IoT and dashboard. So Bluetooth is, it's a short range communication technology integrated into most smartphone and mobile devices, which is major advantage for personal products, particularly wearable. Bluetooth is well known for mobile users. And this is another one is important one. The most popular IoT platforms, dashboards for data visualization. We are seeing the connection networks, protocols, and platforms now. That is, Things Board is an open source IoT platform for device management, data collection, processing, and visualization for your IoT projects. Think Board platform. Then Things Stream is intelligent and global connectivity platform. Okay, so low cost, low power. And ThinkWork is delivers tools and technologies that empower businesses to rapidly develop. And Things Peak is the open IoT platform with MATLAB analytics. So these are the IoT platforms which are needed. Then application of the dashboard in healthcare. Okay, today healthcare professionals gather a lot of data, but it is often scattered between various departments. Okay, so healthcare metrics, healthcare analytics, healthcare reports, all sort of things which are we can provide using the dashboard to the patients. And this is the type total patients. discharge patient count, the average treatment cost, the average waiting time, available tariff. So, like this outpatients and inpatient trend graphically they can show. This is the healthcare how the dashboard can be useful. Then, what are the indicators? The hospital key performance indicator. So, as I told you in the railway station, how we have the key performance indicators, here also giving you the principal metrics on the major category you need. You can track the patients your hospital welcomed over a certain period of time, how much their treatment cost, how long they had to wait in the emergency room before seeing doctor. Like that, these are the things that we can provide for patient. These the Saint Martin's Clinic. Then is this healthcare dashboard template. In this, you can also see example questions asked survey patients. Okay, so patient and staff management, then how many nurses are available, then status of surgical rooms, and the likely day or night shift can be assessed and adapted accordingly. Then another one is the industry 4 in the industry resolution, that is the factory. Okay, smart factory defines the concept of smart factory, can collect the data in cloud, treat them through artificial intelligence algorithms so as to optimize the operations, reduce the cost through preventive and predictive maintenance. Okay, so then industry 4 using IoT dashboards, smart metering, whether measuring energy consumption, as I told you, asset tracking. Okay, so now these days we have a the Dharani portal type. Okay, asset tracking. This is another example. Then this is the soil monitoring. Okay, things board platform. With the help of the things board platform, we can have the different types of soils. Okay, what would be the weights, monitoring the events, all these things we can do it. And there is a fleet tracking is a management system, that GPS tracking to monitor activity of fleet vehicles and assets. Okay, then this is the things dashboard. Fleet tracking, bus tracking, as I told you. Like this dashboard, it will give the indication. And most well-known feature of IoT integration in gyms and fitness business, the workout schedule may be adjusted to fit the individual properly. And furthermore, such devices make it simple to track your fitness program. Wearable device, as I told you, we can capture the information such as user's heart rate, body temperature, calories burn, then home automation, high level security to prevent the access of the home to intruders. And the state of art of IoT is RFIDs to identify and track the data of things. The sensor is to collect and process the data to detect the changes in the physical status of things. And smart technologies to enhance the power of network by devolving processing capabilities to different part of the work, and to make the smaller and the things have the ability to connect and interact. And these are the research groups, those are working: Cambridge University, EPC Global, and EFIL, Nokia, SAP, IBM, Google. All people are working in this particular research group. Then challenge of IoT is how to convincing the users that IoT technology will protect their data and privacy when tracking. Legal and regulatory, technical control, social ethics, market self-regulation. So finally, the summary of this particular IoT and dashboard is IoT provides a platform that creates opportunities for people to connect these devices and control them with big data technology, which in turn will promote efficiency in performance, economic benefits, and minimize the need for human involvement. And it's the most important development of the 21st century. This is the final summary of the particular OT. So we have seen in the case of a dashboard, what is a dashboard? So why you are using the dashboard? What are the benefits of the dashboards? What are the constraints of the dashboard? What are the different types of the connections, platforms, protocols related to the dashboard? And case studies are how healthcare we will use, business how we will use, transport how we will use. We have seen. Now it's time for the participants. I'm giving 10 minutes. You can interact. Any doubts or clarifications, you can interact. With that, I will try to close.
Participants, if you have any query, any questions to ask, you can unmute yourself and ask the question. Or you can put it in the chat box. So there is one question by Purnima. How significant is big data analytics in the design of dashboards?
Yeah, here the big data analytics means, as I told you, that by incorporating the AI techniques and in fact, the as we have seen that different IoT data platforms has come into picture. Basically, people are using the things IoT platform, which is based on the big data analytics only. The how best the data that we are using, the efficient way of the using that particular data is first constraint. As we are seeing that the the in terms of the grouping or numbers or the what type of the data that we need to incorporate for the better understanding. Okay, so in that, while designing, as you said, the big data analytics, the big data analytics as itself, it will not come into picture of designing of a dashboard. So normally the concept of a particular dashboard is we will try to what you can say give awareness to a particular person to within the less time he should grasp and he should understand the concept. So that is the meaning of the dashboard here. Of course, the as you said, the big data analytics means especially analytics will not come into picture. But when you are using the IoT platform, there we can use. Next one.
Yes, any other question, participants? Sir, which platform is more popular for dashboard designing of IoT?
Yeah, that's what. There are two things. Things and think form data dashboards are there. I have shown three different types of dashboards I have shown.
Okay, but sir, which one is more popular one?
No, that's what, madam. Of course, in the sophisticated countries, people are using the things IoT platform. People are using actually things.
Okay.
Of course, there are a lot of applications which we can have, and that's what I suggest the people. There is a lot of scope for research. So for everything these days, just now people are asking about the big data analytics, then AI, machine learning, IoT. So combination of these things. So definitely you can make a different type of novel thing. And my the humble request is, so please, whatever we discussed, of course, this is a not end process. There are a lot of applications, especially in the case of, as we have seen, the agriculture farms, how which type of soil we need to take and when we need to seed. So there are a lot of applications in terms of the transport. I will give one example because I submitted one project that is actually the IoT based machine learning in the application of cyber security. So we can identify the drowsiness of a particular driver when he's driving a car. So in the outer ring roads or the express highways, expressways, so nobody will not be there when the people are driving the car. So the we need to give the alertness to the other part of the people who are driving, because during the night times the people they will drunk and drive, and there is a drowsiness immediately when they get the drowsiness. So there is an alarm that will give to the other side vehicle. Not only that, in cloud we can collect the data and we can send it to the cyber police station. Automatically they will record and they will try to capture that particular person, or they will give the alarm to that particular vehicle, so that there is a attention they need to take. The second one is the elderly people. Actually, these days actually there is a some Algeria type of the, as the old people are the reaching, they have the memory loss, and they have different types of problems they can come across. So in the health the hospitals, so they want to tell something but they could not express their particular feeling. In such type, if they get such type of the feeling, automatically their emotion will be detected by the sensor, and this particular the sensor will activate. They will communicate the information to the sister and doctor. Automatically sister will come and inquire. That is one aspect. And the third one is the drone technology, how we will useful in the agriculture. So the drone, which type of pesticide we need to use, so what would be the threshold level of the crop when we need to cut. So like that, there are number of applications are there. You please, you please take such type of applications, make your students to work together, and prepare a small project and submit. Definitely, you can get that project and you can improve your research domain. Okay. So like that, we can use this particular session and submit the projects. Okay.
Participants, any other questions?
So for software, there are actually now the real-time operating system softwares are there. Okay, so and most probably the people now for real-time domain, they're using the Python, and for AI-based approaches, they're using the Python programming they are using. And of course, application-wise, there is no as such software we cannot say, but depending upon the application, we can use that particular the IoT research applications. So most probably the Python people use, we can connect it and we can implement real-time domain. So I observed Python people use. You please note down my number or mail ID in website is there, or kishorefr@gmail.com, or kishort@nitw.ac.in, or my number, I think organizers know. You can WhatsApp me and you can share, And if anybody interested to collaborate to work with NIT Warangal, definitely I'll be there to help you and we can work together. Okay. So with this, I think my part is over. So over to Veena madam.
Okay, sir. The session was really informative and interactive as well. Thank you, sir, for sharing this valuable knowledge with us. It will be definitely helpful for IoT system designing. Participants now will have a lunch break for next 1 hour, and next session will start at 1 p.m. Gentle reminder to fill the attendance cum feedback form. The link is shared in the chat box. Thank you, sir, once again.
Okay, thank you very much, madam.
Mm.
Okay, convey my thanks to Dr. Mamata madam. Is there or not?
Yes,
Yeah,
yes, she is there in the meeting.
Yes,
Thank
sir.
you so much, madam,
Thank
for
you. Thank you, sir.
inviting me. Okay, madam.
Thank you, sir. Thank you. Really informative session, sir.
Yeah, yeah. Namaste, madam. Okay.
Okay. Thank you, sir.
A very good afternoon. AP Shah Institute of Technology. I welcome all the participants to Faculty Development Program on IoT, a journey from sensor to server. I'm honored to introduce next speaker for the day, who is General Manager in R&D Embedded System of Schneider Electric India Private Limited, Mr. Yusuf Sheikh. Mr. Yusuf Sheikh completed his BE in Electronics from Mumbai University and Project Management from IIM Ahmedabad. Sir have 20 years of experience in embedded product development for power products, agriculture products, and edge devices. Different projects executed in L&T, now Schneider Electric Limited, General Electric, and BCH Electric at various R&D locations, India and international. Sir handles multi-technology projects and influences innovations within organizations. Sir holds 25 plus patents in field of protection, metering, control, and communication. Now, I invite Mr. Yusuf Sheikh to discuss on the topic of industrial IoT, that is IIoT, monitoring industrial products using IoT. Over to you, sir.
Thank you, everyone. First of all, check, am I audible?
Yes, sir, you are audible.
Okay, is it possible to turn on my screen? Am I visible now?
Yes, sir, you are visible.
Okay, thank you. I hope there is no limitation of bandwidth, because of which I may have to switch off the video.
No, sir, there is no such
Sure,
limitation. Yeah.
Perfect, perfect. I'll just switch off my background screen. 1 second. Yeah, this looks better. Okay, good afternoon, everyone. Thank you for the brief introduction. I again, talk about what are we doing in IIoT related to industry environment. How do we go about? Should I start presentation and then followed by Q&A sessions in the end, or in between someone will stop me and ask the questions? I'm okay with either of them. So let's set the context and then move forward.
Yes, sir, you can share. Yes, sir, you can share your screen and start with the presentation.
Perfect. Okay.
Yeah.
Is my screen in full mode?
Yes, sir. Presentation is properly visible.
Okay. 1 second. Are you able to see the other screen also?
No,
or
sir.
only the presentation?
No, sir. Only presentation.
Perfect. Okay. This is what I wanted to know. Sure.
Okay. Yeah.
Let's start. We all know what IIoT is talking about, starting from sensors to machines to intelligent robots to edge devices, cloud access, and then predictive analytics and maintenance and so on. But in the end, what really IIoT is about, putting everything together to drive and achieve business goals. That's the final aim of the entire technology or entire process that we follow. It's basically interconnecting the assets. You talk about machines, you talk about equipments, you talk about warehouses, inventories, for example, and you add an embedded solution to it so that the data is available for you for runtime monitoring. The most important of all in IIoT is accessing the real-time data, which is very important, and then move towards analyzing the health of the machine. It also somewhere related to manufacturing, supply chain, asset tracking, at least to forget about worker safety. Also going forward, because of this pandemic, we are looking at now customer relationship improvement. Automation is really helping us. A step forward, now we are largely busy in developing algorithms for machine learning and artificial intelligence that can be easily deployed by end customers or system integrators. This is what we are working on now. You all know about this evolution of industrial, IoT journeys, where we moved from IoT 1.0 to 2.0, where we moved towards steam powers. Now we are talking about electrical powers, and 4.0 is all about computational power, where we have a lot of data available. You interpret data into it and make a useful information, and then use it effectively for a business benefit. Going forward, 5.0 holds what we don't know, but it will be more of a marrying between machine and man. It will not, machine will never ever replace man, because of the simple reason that we have intuitive power to think beyond, take corrective actions and as and when, and go in on a frugal innovations. So 5.0 is much awaited, but still, I mean, we need to look further. Till 4.0, we all have connectivity thanks to the technology, where we are able to gather the information, share the information, and effectively use it for manufacturing process and so on, what I talked about. The most important thing is, it has really helped us evolving in a better processes in terms of error proofing. The kind of, latency that we used to have, the kind of rejection that we used to have in the end, if the yield was suppose X, if I can give you a number in 89% of the value, now it has come down, drastically improved to 99.99%. So you have very less and less rejections. Also, looking at the production and maintenance cost has come down drastically, where we used to do periodic maintenance every 6 months, even if the machine requires or not required. We have gone to a level where we know at what stage the maintenance is required and to what part of that machine, not the entire machine that we are looking at now. So it's resulting into more automation and remote access and control for us. Sorry for in between, I'm not feeling well, so I may take some time. So what holds challenges to us in terms of IIoT? Number one, we have a lot of legacy and outdated systems in productions. Some are as old as 1960s, 1970s. We are not don't want to stop the production and move over to the improved version for the clear sake of losing the ROI, return on investment. Per se, at the start of the project, even we don't know what is the ROI for a given project. So we actually start with proof of concept, make it happen, and then deploy it across all. So that's also a second level of limitations, where upfront people will ask, what is the return on investment that you likely to give me? Upfront answer, I don't know. But over a period of time, we have evolved some methods and some solutions where we know, okay, this is what we can do to achieve things better than what we are today. Practicality is one most important aspect, and utilizing the data. I mean, the moment you start gathering data, you have n number of points available. How do you make sense out of it is really very important. That's where I need help from people like you who are into industries, who are into trainings, who are into academics, who can evolve a better empirical formulas for us to use it and then deploy it for machines. I don't want to divulge much on the digital transformation need, because we all know, because of pandemic, everyone has gone home, and because now we have third wave coming up. So a lot of restrictions again being imposed again on us. One thing what has really happened is, there's a paradigm shift in customer as well. They also started accepting that, this is the way we go forward. Let it talk about augmented reality. We are talking about vertical integration, not only vertical, horizontal integration as well. Earlier we were talking only about integration of a manufacturing line. Quality also wants to be part of it. Supply chain has become really part of it. Even the R&D, which was a backstage support system, has become part of it. So no one can remain in isolation anymore now. More and more robots or innovation that is happening in SCARA that has helped us. the system which is helping in big data analytics is really coming forward in terms of the hyperscale providers such as Amazon, Google are really helping us to develop the platforms which are really fast and ready to deploy. We are going forward with additive manufacturing, where you deploy one machine, you add on to second machine to it, becomes a complete set for you. You break it into and add a third part to it, you make something else out of it. So that is also a lot of innovation that is we can say even in terms of vendors who are supporting us to make system available. In terms of digital transformation, what we see is customer experience becoming very important. I'll just share one slide which I find to be very useful. Earlier, the paradigm of product was more of a devices. You sell device, you sell service in terms of only to that part of commissioning, and then you provide support. Now what has happened is device is owned completely by the manufacturer. It is deployed at the customer site. You are able to use it effectively for customers' benefit. Earlier we were selling the spares. Now we are ensuring that those spares are utilized properly, and then we are converting from product to services. So customer who is not expert in the power products doesn't have to care about it. The ownership lies with the manufacturer, and it's a win-win situation for both customer as well as manufacturer. So that customer can focus on what his core expertise is manufacturing things which he really wants to sell further, not in devices which are not core to him. And this is where the IoT is bridging the gap. Thanks to the innovation, again, I would say. IT is playing very important role. The gateways available, flexibilities, innovations, and efficiencies. The key to it is deploying and exploiting the software, the IT's algorithms. That is what making it more interesting for us. I hope I'm not going too fast because of this post lunch. I know everyone after the lunch, finding it difficult to keep their eyes open. But really interesting for everyone to understand how IoT can help industry to evolve in a better form. So if you want me to stop anywhere, please raise your hand, or please stop in between. I am ready to answer the questions. I know I may not be able to touch base with each and every one of you, because since of the digital isolations, we don't know what's happening across the screen. Right. Okay. I keep on talking about technology. So in terms of communication, we see a lot of evolving happening in terms of protocols, Modbus, Profibus, TCP, Ethernet. Wireless are coming up in a really big way. We had Bluetooth 2.0 jumping to Bluetooth 5.0, 5.2 coming up now. LoRa, NB-IoT. All this are really helping us to select the right technology for right product. So there is no answer to there is no one answer to any solution. You can select any technology and deploy it as long as you're reaping the benefit out of it. That's what the idea is. For example, high-speed internet is becoming very, very popular. But do you really need 1 Gbps speed or 10 Gbps speed for data communication, which is from sensors? That's a question to be answered. For me, I'm happy with 10 Mbps, 100 Mbps speed now. The moment I go to a webcam, 100 Mbps speed is good enough. But then where do we deploy to 1 Gbps speed is something we really need to look at, where you have a lot of critical data handling to be done. One example where I can talk about is HSR, high speed redundancy, where even a latency of 1 millisecond can really affect you. In case of data centers, people deploy it very effectively. That's where Ethernet, TCP/IP is helping in a lot of ways. I mean, I'm not talking about only network. It's also the efficiency of the network to correct itself, the collision avoidance, the data handling. I mean, just imagine two people talking on the phone. One side, not able to hear. The other side says, "Hello, hello. Are you able to hear me?" The other person says, "Okay, wait for a second." And then he waits for they takes a pause and then again says, "Okay, am I audible now?" I mean, I don't know what people does in between, God knows, but they feel that it's auto-corrected. That's not what I'm talking about. It's actually at network layer where there is some corrective action which is happening even at bit level, where you see the correction happening right from a packets which is being transmitted, checking its validity, and then transmitting it to the customer and customer in the right form. This is what has evolved better. So low data packet failures that have happened, which has helped to take more and more data decisions on the network. So we are moving from decentralized to centralized form only because of network improvement. Just to give you a flavor of different network layers that we have, we start with the bottom layer. We call it connected devices, with the devices which are closer to the end use. So it will talk about numerical relays. You have meters, you have drives, you have circuit breakers, and you have for motor management, you have motor management relays. On top of it, you have a device which takes the data from this end devices and push it to a network. Sorry. Ideally, we call it gateways. We call it edge devices. I'll come to that later. And we have a lot of host of devices cater to this platform. So we have relay modules. This relay module is intelligent module, which will configure its devices according to the need of the customer. So there are 36 parameters which can be configured, which can tell the user that there's a problem in network, there's a problem in the end devices in terms of overloading, short circuit, and blah blah, whatever you call it. So it becomes very useful to the customer to take decision at local level also. Before you throw the data at cloud and then do the computation, get back to local, well, by the time you have disaster happening. So in order to avoid that, you divide the levels into critical zone and non-critical zone. Non-critical zone, you can take it further. Critical zone, you have to take decision right there and there itself. On top of it, you have apps and analytics, where a lot of innovation is going on now. We are working on a lot of simulation models, where twin models we are creating, where the physical devices will actually continue to work in the field. And on top of it, the devices which are there on cloud will try to simulate the field conditions, and it will be ahead of time. I'll come to that later, how we are doing it. For example, just imagine your device is working at 1 o'clock today with some data packets and some loading. You'll be able to predict what will be the state of this machine at 1:30 or 2 o'clock. Wouldn't it be great to know that what will be the future of this device in terms of MTBF or MTTF? This is the kind of algorithm that people are really working on now. I'm sorry for my bad throat. This is one such typical example where we have a power distribution for low voltage panels. You have power coming from transformer, which converts HT or MT 11 kV, 33 kV to 440 volt. From 440 volt, you have divisions, either to power control centers, to main distribution boards, and then on every floors you will find some main distribution boards, and below that you will find the final distribution board. So this final distribution board, I think you must have all seen at your home, where you have a lot of MCBs and ELCBs nowadays being used. And for specialized applications for VFDs and power factor controllers or motor controls, we have MCCs and VFD and APFC boards available. All this follows 3 edge levels. One is connected level, one is edge device, and one is application level. Okay. Sorry, is there any disturbance in between?
No, sir.
No, sir.
Okay. Shall I continue?
Yes, sir.
Yes, sir. Yes, sir.
Okay, thank you. Yeah. So please make a note of these points, which are very important. Not everywhere we can jump to doing R&D. We need specialized people who are actually deep diving into each and every segment. For example, electrical parameters, I call it metering. because this is becoming very, very critical for decision making. Earlier, meters used to have class 2, class 1. Now you see even class 0.2 is becoming, very heavily deployed. Earlier it was only current, voltage, power, energy. People have started demanding even THDs, individual harmonics, as a corrective action that they need to take further, and accuracy on those are becoming very high demanding. You have three-phase three-wire system, you have three-phase four-wire system. How do you gel those together and make it a user-friendly network analyzers, where you have runtime data. One such example I can give you, where today we have started deploying in our switchgear products. Just before trip, what was the wave shape? 5 cycles. And after trip, what was the wave shape? 10 cycles. So the entire 15 cycles data just before the tripping or the fault clearing time is being stored, so that afterwards it can be retrieved and then analysis can be done, which will become very handy for the customer to know where the actual fault was and how to go about correcting it so that it doesn't happen again in future. Remote monitoring was one key parameter. Now it is people really want remote operation as well because of safety reasons. So no one wants to go to the panel, open the door, and do the operation. They really want to operate it remotely. So if I want to go before near the panel, I'll ensure that MCB is stripped. And how do I trip the MCB? Not by hand, but through remote operations. So motor operator is becoming very popular now. Status of motor operator is being taken to the SCADA systems, and then from SCADA system you can issue the command before the lockout tagout operations can happen for safety maintenance point of view. There is one more nice algorithm that has come up, where you don't actually necessarily trip the breaker, but you reduce the level of fault to such a level that even if the arcing happens, it doesn't hurt the customer or the maintenance person. For example, if the actual application of short circuit or instantaneous tripping or overloading demands 10 times or 12 times of the value, during maintenance you can temporarily lower it to 2 times or 1.5 times, and after the maintenance is over you can bring it back to the normal. That's the key algorithm that people have started putting into the products. Digital connectivity is becoming very, very important. Every single product that we deploy has some way or the other connected to the SCADA. So either directly, indirectly, either to compute available on the product or through some tertiary means. I mean, it all depends on what is the end requirement is. Condition monitoring is one such parameter. Suppose sitting at my closed room, I know whether my breaker is in active mode, alarm mode, or pickup mode. By that, whether I will be able to know at what time the fault is going to be cleared, what will be my temperature at that point of time, how much time it takes for my temperature to cool down, when I can resume a normal operation. This is what something really becoming very topic of discussion today. A lot of innovation, lot of R&D is happening in this direction. So a device which was earlier being operated or maintained by a expert, now device itself has become expert. I am able to tell my own health. Just imagine I go to doctor and say I have cough, I have this thing, give me this medicine so that I can recover better. This is what the prescriptive maintenance has started becoming now. So device itself is able to say, this is what the number of operations has happened to me. This is what my total life remaining. So please ensure that I get maintenance at this point of time. Going next, there are a lot of tools which are becoming very popular for customers to use it, like configurator tools and commissioning tools. Earlier, I used to give the device, and they used to call one expert to use the device and put it into the network. No longer the case now. If I'm selling the product, I ensure that I give flexibility to customer directly use it as it is. Just imagine, for example, you are using your mouse, where you just hook on to your USB device, and the mouse is auto configured. The drivers what is required are auto loaded. Same thing is started happening in terms of industrial devices now. You hook onto the device, everything gets automatically flashed onto your screen. You configure according to your need. You verify it whether it's going to suffice your requirement in terms of network availability. and then deploy it. So you have two modes now. One is test mode, and one is actual deployed mode. So in test mode also, you can actually simulate the entire conditions of the devices. So before you deploy it in end product, there is no hiccups. So you call it simulating, you call it emulating, and you call it deployment. So a lot of advancement we are doing in emulation. And last but not the least, asset management, misnomered. People grossly use it the way they want it. It all depends on how the customer wants to manage it. It's not something that we would like to force upon to the customers. Okay, hey, you want to use it for 10 years or you want to use it for 15 years. It's actually up to the customers. How he sees the trend in terms of evolvement of his business. So one such is we are talking about is asset tracking also. Really, do we need to track the panel, large panel? The answer is no. Do we really need to track the tools? The answer is yes. The tools which are used for mold. There are some critical tools. In a factory, you see hundreds and hundreds of tools. You want to identify one tool from where it is located, then it makes sense to use it. And in the end, we all roll down to 3 levels. We have connected, edge, and apps and analytics. So, I mean, you can be focused on any one levels and yet achieve excellence. I largely look at the connected devices and edge devices. Edge to some extent, connected to large extent, because that's something which is actually controlling and power distribution and loads. So taking it further, I want to engrave that at every level we work. So that's why I just bring in these 3 levels of product and solution every time. So from past 2 slides, you will see me bringing out connected edge apps, connected edge apps. But this is what something really very important for people to understand. Not just one level will help you achieve the IoT solution. It's across all the 3 levels that you need to connect dots. So for the bottom layer, what I just mentioned in earlier slide, where we have power coming, then you have power control centers, you have main distribution panels. Here, just to name few the products that we are using, you have meters, you have ACBs, you have MCCBs, and you have NPR, new protection relays, which we call it feeder relays. See that connection to your panorama? I'll just pull out. Yeah, over here. All the devices in some form or the other are connected now. The legacy product where we had C-Power ACPs was not communicable earlier. We made it communicable through a module called UNCO, close open module. So you're able to remotely see the status and control it. Then you have distribution boards, submit distribution boards. Mostly the components that are used is MCCBs and MCBs. Those also communicable. Then you go to motor control centers. You have VFDs, intelligent motor control centers, power quality solutions, where you have motor management relays, motor relays, drives. Even simple contactors are communicable nowadays. I'll explain how. And then on edge devices, you have Panorama, which is largely a TCP-based solution, which not only provides a gateway, but also has embedded web pages to configure and to view the data. Suppose if I don't want to go to 3rd level, I want to view the data only at the 2nd level. What is the status of my devices? I can hook on to my network, just open the page and see the status. It's as simple as that. It also has a means to log your data. Whatever critical data that you have. For example, there was a customer who wanted to log temperature every 15 minutes for 2 shifts. You are giving flexibility to the customer. Tomorrow, I want to add a certain one more module to it, is sitting beside it, where 2 devices throw the same information for redundancy. We can do that over here. And AUCOM, largely for SMDBs and FDBs, where even the MCBs and contactors are able to throw the information on the network, and you're able to remotely control it. You have a remote monitoring unit where the latest GPRS information on MQTT or NB-IoT is thrown, and also the GPS information, if you really want to know the asset location, is able to throw on. And the beauty of this is all the Modbus memory map. I hope you're comfortable with Modbus, because I'm giving the example of the lowest level networks that we use it. Sorry. Modbus has, every device will have a Modbus memory map. Uh, what we deploy a Modbus memory map can have registers of up to 3,000 to 5,000 elements. Uh, it's become very cumbersome for customer to configure every time, and every new update comes, he has to reconfigure it again and again. So such devices help you to do away with that configuration. It's a pre-configured, so you just load the latest file, and you have the latest parameters available as configured values. So if you want to view average current, average voltage, average power, you just drag drop those parameters, and those data are available on your screen. So you don't require even to go to third level. Okay, and then you throw all the information on the on the servers for future verifications and future record maintenance, report generations. I hope I'm clear till this point. Because this forms a really very base for all the IoT devices that we use. I hope we follow the similar structure for everywhere. You talk about any organizations, you talk about any domain, let it be agriculture, let it be lighting industries, or let it be power industries, let it be data centers. They follow this structures. A bit modification here and there to suit the requirement is acceptable. So what customer segments we target? We target across all. We target industry segments consisting of textile, sugar. Defense is very big segment for us, a very knowledgeable customer who actually drives whatever you say has to be demonstrable. We also cater to food and beverages. Pharma industry is becoming very, very demanding. The processes are becoming very, very demanding. No latencies, no delays. Automobile industries, because of this recent pandemic, also becoming very demanding in terms of data availability on networks. Building segments, we have data centers of topmost expectations. Even high-end residentials, I was surprised to see. I started, expecting the data centers available for their local monitoring. Recently, a lot of IT parks coming up, hospitals, healthcare centers. In terms of utility infras, we cater to metros. You see metros coming up everywhere. Airports are becoming very, very sophisticated, and in terms of data management, they're becoming very, very complex, because we don't have to comply to only local standards, also the international standards that we have. Even the municipalities and the water supply centers are becoming very, very informative about data management. So one such case was Gujarat Water Electricity Boards. They wanted to monitor the power delivered for single phase motors in each and every houses, so that they know how much power is being utilized by the end user, and how much time he's keeping the motor on, so that they'll be able to use it effectively for future water supply management. Very good thought process. So people are evolving in a better way, because technology is available for your usage. How do you use it is up to you. So you create a business case, and then you start you using it. In terms of OEMs, we have telecoms working on with Vodafone's. We have one such project that was running on, and textile equipments, we have a lot of projects running on. So largely what we look at is product development, which will cater to all these customers. And we have IoT also from manufacturing testing point of view, so that we are able to manufacture a larger quantity of data or larger quantity of products, so that we can boost our sales. I'll come to that part also in some time. So reiterating the edge devices that we use, Panorama, LN Touch. The touch panels are becoming very, very popular. I mean, I would say earlier it was only for local visualization. Now it is not only local visualization, also takes a different data from different devices, and you're able to store the data in it, and you're able to modify it on the go, the screens, the way you want it. So shift one will have different screens, shift two will have different screens, and so on. So this is becoming very, very critical for local monitoring purpose. Also, the kind of interfaces that I've seen has evolved in a better way. Earlier we used to have only one port, 232. Now you see 232, 485, TCP, proprietary. I have seen CAN port available, USB, for example. So you just name it, and how do you want to connect to the system? You have it, and the user interface I've seen beautiful. Objects you just drag drop. It will tell you what all things to be done. You just write a few line of codes, bare minimum code. A training of a day or two good enough for you to become expert in it. Not only in this, even in PLC, you can become an expert. The PLRs available in the market are really very helpful. We have this M3U, I call it Modbus and Memory Management Unit. It's not only a communication module, it also uses for remote interfaces with the breakers. So if you want to remotely turn on, turn off the breaker, you don't have to add anything more to it. You just have to use this motor operator and the breaker. So this is not only for communication data, but also for control action at local level. That's why it's very popular now. You have data available of the breaker or of the devices stored here. So if anything goes wrong with the devices, you can retrieve information from here. Relay module I just told you mentioned earlier, where you can configure it for n number of events and actually help customer for local diagnosis and for indications. And remote monitoring unit I just mentioned for remote alarming and communication, GPRS communication. So just give you a flavor of how the end devices communicate. One second. So you have a MCP sitting here. This AUCOM will take the status of MCP and throw the information to your SmartCom. Now, suppose if I want to turn on the MCB, I say on command to this. This will not pass on the on command directly to the MCB. It will process it and saying that I have the status which says MCB is on or off. So if the MCB was already on, why do I need to turn it on again? It's a wrong command. So I inform back to SmartCom saying that the device is already on. Please verify at your end whether you really want to do something else. Whereas in earlier age, we used to just simply pass on the information. Now we are able to process it in a way that what action needs to be taken is actually taken. So if the breaker is on, you don't accept on command, you only accept off command. If the breaker is in overload or alarm mode, or if there is some critical fault going on, you really want to turn on the breaker, the answer is no. So you avoid that kind of commands also. And so suppose there is a critical fault happening and you want to turn off the breaker, you actually do instantly. So you don't wait for further analysis to happen. So this is what the actual scenario looks like. So right down at the final distribution boards, you are able to control. Not too very popular in India now, but it's gaining a lot of popularity in Europe and US, where people want to have at house level the MCBs. One example what I can think about is now smart meters, prepaid meters, where you have prepaid card, you flash it, it will recharge it, and then you can use it for that particular time. After that, it will simply switch off. So you need to recharge again. This is something similar action that you expect in future to happen, where now physically there will be no cutting off your wires if you don't pay the bills. It will be a smarter way of switching off and switching on again. So this is what one such technology being deployed across all. If you look at the anatomy of IoT, where an event happens, you analyze the event, you measure the value, you put it onto some a system, you then give it to some central processing unit, and then a key aspect of it is analyzing. This is where 90% of the time now we are spending on. How do we aggregate the data? How do we analyze it? How do we generate information? And how do we take action so that it doesn't happen again? Or if it's in a favorable condition, it sustains that for longer time. One example I can give you is a breaker. I am going back to the breaker again because I hope people will understand that in a better way of MCBs, and you have AC at home. Now suppose if the bill is coming higher, For what reason, you don't know. Now, suppose there is an AC which was 5 stars, claimed to be 5 star. You know the current consumption of per hour has to be only this much, or the power consumption has to be this much. You can keep on analyzing it. Not you physically setting it. You can deploy a use case, and where you see if my analysis of per hour goes to something higher, I say something is wrong with the AC or something else I need to look at. So that information is also thrown to the customer. It doesn't give a shock at the end of the month by coming a high bill for the customer. Very powerful slide. I would like you to have a look at it. What we are working on now is this is the end device that we have on the field. We keep on taking the data from the device and then have a local analysis, and also we have created a simulation model so that the entire replication of this device is available on my network. So what I do is, if I want to modify something, I do it on simulation, I test it, and then once I'm convinced that it's not going to affect my regular operation, then I deploy it on my actual field, and I keep on upgrading my system. So this is a live runtime process that keeps on happening. So I request you to come up with a lot of simulation models like this, where not only current, voltage, energy, you also have environment factors coming into, like vibrations, leakage, corrosive environment, humidity environment. How is it going to affect your system, and how do I safeguard my application? So I mean, one such use case what I talked about was temperature. Just imagine, the thermistors are being deployed on the bus bar panels, where I'm able to monitor the temperature of the bus bars. Now I know what is the temperature going on now, and through the business model, through the simulation model, I know what is the maximum limit that it can sustain for that particular current. So if the current starts going beyond certain limit, I can shed certain loads. We call it load shedding, and then bring back the temperature to a level within the limit. If the temperature goes below certain level, I know I'm in safer zone now. I can switch back non-critical loads back, and then let the temperature to come to a stable value, without anyone's intervention. One more example, what I can give you is, like earlier days, you used to see a maintenance person going from one panel to other panel, noting down the values. No longer the case required now. This is you just go with a flash card, just tap. The entire data is available to you. You go back to your main servers, tap it, and you have the data. So that is form of connected way. You can have it directly centralized way, where on communication you get the entire information. It all depends on the customer, how you know safeguard he wants to have it on his data. So if he is too choosy about having a local network, we are okay with it. I mean, we don't have any problem. So because we also respect customers' privacy. I hope this slide is clear to you, because this is where I need a lot of help from academics and people who are connected with industries, and also working on newer technologies. So almost 80-90% of the time we spend on this, because we have come to a maturity level. We know what needs to be done. Now we want to further make it refined in terms of future ready devices. So a lot of innovation happening in terms of sensors. We have a lot of sensors being deployed. I call it a lot of in sensors also. I call it transducers, more appropriate word. So you have sensors and available for temperature, humidity, for IP65. Going forward, you will have a lot of sensors for even arc flash sensing, where you're able to sense the arcing between the joints in less than few milliseconds. I'm talking of the order of 2 to 3 milliseconds. You're able to distinguish this arc with a normal light. So that's how the innovation is happening, and you have a lot of new sensors coming in the market, which can even know the burning of the insulation before it actually ruptures and gives you a failure indications. This is the SmartCom that we offer to the customer. It's a SCADA package. It has host of value adds. At a glimpse, you are able to know the entire plant status. I am going to give you some examples. We have deployed it even in Baroda and critical airports also being successfully being used. And the beauty of it is you can keep on updating it at the background and then effectively deploy it on the go. So there is a latency of less than 1 millisecond. So you can see that kind of speed that you can achieve. It has a lot of report generations for end users. So if customer wants in certain format, you can have it in certain format. If he wants to have it periodically update of those formats, you can update it on the fly. The parameters monitored on the fly. So you can have critical parameters for a certain day of the time, and then switch over to certain other critical parameters for some other applications. That also you can do. A lot of time people demands for MD, energy, and report generation for the same. So this is what largely 80-85% of the customer in India demands that. But if you go outside, it's much more than that what we do. We have multi-level of access to the customer. So a maintenance person can only view certain parameters. He cannot go beyond that and beyond the purview of that particular bay. So if it's authorized to use to view parameters only for three panels, he can view only for those three panels. He cannot go beyond and see that. A plant manager can see the entire plant, but not the plant B. Then comes to MIS, Management Information System. They can view the entire plants sitting at central location for plant A, B, C, and try to see what is the efficiency, what is the rollover data that they get, and how do we optimize it, how the plant asset utilization can happen, and so on. So a snapshot, we are able to see that. So this also has a linkage to SAP. So you're able to correlate with the SAP data and then make the data available for your for users. Excuse me. These are the different device configurators I was talking about. So one such example I give you is, I showed you about this AUCOM over here. Yeah, over here. So even this is available with the monitoring system. A simple user interface where customer knows that the breaker is on or off and what is the alarming positions and how whether you need what is the configuration that you have. Rather than going to expert and asking for his advice, he's simply able to buy it from the market and deploy it. I mean, it's not so simple as it seems, but yes, he's able to. The way it was handled earlier, things have become much simpler now. Okay. This is one such configuration that you talk about, and the beauty of it is you can do it configuration one time, and if you want to deploy it in 100 products, you just hook onto the network and then say flash. So entire data from one device gets flashed to other devices accordingly. And if you want to take data from one device and put it into network, you can do the same thing. So you have a list of histories also, the event log, who did it, when, why, everything you want to have for ready reckoner, you can use it. So it's not a full-fledged smart com. It's only the configurator basically, but good enough for you to view a few devices on one panel. So suppose if you have commissioning certain things, if you want to see, okay, this network, is it going to harm my network or not? I can test it. I can generate a report to the customer and say, okay, if you deploy it, there is no harm that is going to happen. So a lot of innovation happening here also. I mean, I would urge you to look at .NET, VB. Simple applications like that also can help you evolve with a lot of user interfaces configurators, which is gaining too much of popularity. So mobile apps, you have it where you can configure using mobile apps for devices which are communicable on Bluetooth. NFC is very next good thing that is happening, where you are able to take the data even when it is not powered. One edge device, what I just mentioned about, give you a flavor of it, where I can have 200 parameters monitored in one go without having anything to be written about. So you just say I am connected to a circuit breaker, I'm connected to MCBs, I'm connected to so and so relay. It pulls out the information and throws it to the customer. The customer has to just select what parameter he wants from those list of values of that particular device. And it is IoT ready and MQT, over MQTT and even NB-IoT, you have it deployed across. A very lightweight, and even it is configurable. You can have GPS connected to it, or you can have without GPS. This is the way you configure the device. So host of devices, all pre-configured. Just imagine the flexibility the customer gets. So if he wants to deploy it for one device, he can do it. For multiple devices, he doesn't have to add more devices on the edge level. One device is good enough. From there, you can take it to further up gateways. And the cost is also very good. I mean, earlier days, generations, the cost of a GPRS product used to come to up to around 15,000 to 20,000 rupees. The cost of chip has come down so low. I mean, barring that unavailability of the chips because of this slowdown and because of unavailability at China level pay, barring those issues, the chip for 2G, 4G, or 5G, which used to cost me around $15-20 earlier, are available at $5 to $6 now. And as you scale up the volume, it comes further down to $2 to $3. And the user interface with those chips, either SPI or I2C, very easy. I mean, at the API level, you are able to pull the information. So within a couple of days, you are able to effectively create a model out of it and test whether it's going to be useful to you or not. So thanks to all the vendors out there who are able to work on the different models and make it available to you. So for example, recently we were just looking at one module which had Bluetooth, Zigbee, and one more I forget, NFC on chip with the controller, dual port. So I'm able to access the data on stack level, take it to other controller on the module itself. I don't have to write any of the module level, only write an application code off top of it, wrapper to communicate with APIs, and my job is done. Just imagine, within a couple of days, I'm able to deploy it for and test it at customer site. So this is the flexibility that you get. So even the controllers are becoming more and more powerful for you to evolve with more and more edge devices. So the ARM Cortex controllers, the power of it is becoming immense. The low power devices, the battery operated devices. I mean, feel free to connect with me anytime. I mean, I will be able to give you an example where we are able to utilize one battery for at least a year to 5 years, which will keep on sending information every 5 seconds to the customer, yet not drain it. It will give alarm indication to the customer only when it is time to replace it. So effectively, we are able to use it, which was not the case earlier. The milliampere hour of the battery has gone down, but the effectiveness of it has gone up. Earlier, the battery of this size would come to around 100 milliampere hour. Now you have CR2450, which can give you a 600 to 800 milliampere hour life. And if you couple it with your Bluetooth application, it can sustain for years together. So there is no end to innovation. Please be innovative in terms of applications, in terms of selecting what zone you want to work on. I mean, rather than becoming jack of all trade, I would suggest start mastering one and then deploy it across all. So I particularly started with protection algorithms, and then move on to communication, then move on to controls. Now I'm working on system level integrations where I help people to come up with better algorithms. This is one example where we had deployment of devices. I just talking about few devices here. It doesn't mean it's just one panel meter that we have it. So how do we ring it up to n levels? This is a live example that we had running in one of the fields, where we are able to pull out the information and send it. The key to here data is there should be no failure of information. When I want information, it should be available. That's the job of the integrator, or that's the job of a designer. If the network has broken, how do we store the information into local memory and keep on requesting for healthiness of the information, so that tomorrow, if I have the network available, I can throw the backlogs to the cloud and make system complete. It should not happen. My current is growing, and suddenly you see a dip in the current, and then again you see a current growing. So that gives a wrong interpretation that current went zero at that point of time, which is not the case. Data was not available at that point of time. So that's why the edge device will come into picture. I have seen a beautiful examples of edge devices. One second. Yeah, sorry. I've seen a beautiful example where the edge device was able to pull the information of current from a motor, and based on the current car range, it had put a band. So if it's within the band, no need to send the data upwards. Why to unnecessarily keep on sending 10 ampere, 10 ampere, 10 ampere, 10 ampere? The moment it crosses a band of it, it will send the information, and then it's with the range it will send you. That is, now it has become 10.5 ampere, and that it will send for a certain period of time. And then once the current stabilizes at the breaker level, at motor level, it will stop there. So you unnecessarily stop jamming your bandwidth. So you decide selectively what information you want to send, at what frequency, and at what criticality. These are the several dashboards where even the system was connected to compensators of APFCs where we overcompensated. That's why you will see power factor coming negative, just to test whether actually working or not. Everything going good doesn't give you right information. Sometimes you have to create a failures and then see whether that failures are also reported well or not. Okay. This is one example where we talked about for Baroda factory, where we have deployed it across a system, where we are able to pull the information of energy, and also a deeper level where we have deployed IoT across all the sub plant levels machines also, which I'll cover in subsequent slides. So this is a dashboard where you're able to see factory level what is the energy consumption, and how much is the saving in COT that you are able to achieve. So sustainability is what we are driving largely now in terms of savings, in terms of power, where we switch off the non-essential loads, or the HVAC is controlled properly. A beautiful example where we talked about ATAL Seva Kendra. There was a project that has come up in Rajasthan. I think most of you must have heard about, where power from solar was harvested, and they had their own network available. So they just wanted to know the effectiveness of the solar power being generated and how effectively it is being used to the customers. So they provided a panel where they wanted to see how much energy is being generated out of solar and delivered onto the grid. So we created an entire ecosystem using Atmos servers and our iVision cloud, and also we use the reset networks for throwing the information. And on top of it, we have developed some analytics for monitoring and taking corrective action in case of some solars are not responding to the peak level MPPT. So some maintenance that needs to be done, so that alarming is gone. And also we have integrated that with a ticketing system where people are able to log the complaint, and that resolution happens in the entire system. So you don't have to have a separate network for monitoring customer complaints. You have it right there in that. Okay, I take a pause here now. Done with power devices, done with design devices, done with whatever devices that we make for customers. Now that we are going into communication zone, a lot of devices are becoming more and more communicable. We expect almost all the devices in industry's domain to be communicable in some form or the other. Though at SE level, we are expecting the digital transformation to happen soon, but that is inevitable, of course. But it comes with a new threat, which is cybersecurity. You have a lot of miscreants who really want to disrupt your networks. Energy sectors has come up with some regulations. Chemical sectors have come up with some regulations. You see a lot of regulations coming in terms of meters also, where the use of AMRs has to be regulated properly. So IT with operational technology has to now come together to fight against this threat of cybersecurity. A small flavor of it, so that you are able to understand this is the domain which has opened up in a big way. It has already becoming a key focus area for any product that you make in US, Europe. In India, it is going to become soon the trend. So any communicable device I make has to be compliant to one protocol standards, has to be compatible to one cybersecurity standard as per levels what is required. So for example, for industry in Europe, it has become SL2 a norm. Whenever you have industrial product, it has to be SL2 compliant. Otherwise, you run a risk of having a malfunction, not because of your internal failures, but because of some third party who will be affecting you badly. So earlier we used to develop products which were EMI/MC compliant, electromagnetic interference and electromagnetic compliance. Now we are talking about cybersecurity compliance also. So in an electrical environment, if your product is not to be deterred or not to be affected, is already done. A lot of our guidance and regulations has come in. There is no regulation as such officially in ISO standards or what we see, which are very predominantly saying that without this you cannot launch your product, but becoming very mandatory soon now. So this is what I would touch upon base in next 2 slides. I'll just touch upon the base and leave it open to the audience to drill down further. Becoming a very good roadmap for even career development. I've seen many people opting as a cybersecurity compliance expert in industries. So I, as a designer, will approach such cybersecurity compliant expert. Will try to see how do I make my product more compatible. They will list down the guidelines for me. They list down the test cases against which I have to do the test. Like one such example is penetration test. Then black duck analysis. We have it. All those tools against which I need to comply it, and then I can clear my product approval guidelines. So Schneider is very active in such development. Recent examples, what we saw, we keep on hearing every time again and again, where a machine got hacked, a system got tracked to some locations in either Russia or somewhere else. I don't know. But in the real industry domain, even a simple devices like PLC can get affected. If you have TCP, you are even more vulnerable. If you don't have firewall, you are at God's mercy. So safeguarding your entire system, where it started evolved from process industries, where even the valves are controlled remotely, where even access to humans are very difficult. So you have remote monitoring system where you turn on, turn off valve based on the process requirement, and then you monitor it from distance. So just imagine for a fraction of seconds also, if something wrong, command is gone. You have mixing of 2 chemicals which were supposed to happen sometime later and in some environment, and because of which the entire furnace will freeze up. We'll have to stop it, cut it, and then deploy a new one. You cannot have a redundancy everywhere. So what you do is proactively avoid those scenarios. So you have multi-network monitoring system. You have multi levels of access control. You have different patches which you can keep on updating as and when the cybersecurity learnings happen, because we are not experts in this field. So we also evolve. Like antivirus, we also keep on making antiviruses or antidotes for the attacks that keeps on happening. One thing is for sure. For example, I'll give you one simple example. You make USB-based devices. What if someone hooks onto a device and there are certain handshaking that happens. In that handshaking, I keep on bombarding your device with n number of packets, irrespective of waiting for the device to respond. What will happen? How do you respond to it? Is what ultimately decides, because your job is not only communication. Your job is to, for example, a thermostat. Your job is to monitor the temperature and regulate the temperature. Communication happens to be one add-on feature that you're giving to the customer. So because of this communication functionality, you're able to you're getting affected for your temperature monitoring is not acceptable. So you create a demarcation. If my communication network jams, fails, or halts, I don't hurt my primary function. If something has evolved very well. So you come up with dual core architecture, you come up with multi-core architecture, you come up with different level systems is what you decide. I'll take a pause here and let you have a look at the standards. Uh, there are a lot of standards that were available in the domain. Few tending towards design, few tending towards manufacturing, few tending towards operations, few tending towards security coverage. Uh, Per se, a lot of regulations and nothing specific to one particular industries. So what we came up with, recent relevant standard was IC 62443, which gives a complete coverage of not only in terms of designing, but also in terms of manufacturing. What kind of safety that we need to take care. For example, if a simple example of burning a data flash into microcontroller, there are good number of guidelines. For FOTA, firmware over the air, there are good numbers of guidelines. You cannot simply start the FOTA and update the firmware as it is. You need to pass through certain checks. This standard gives that regulations and guidelines. So please go through it. You will find it very useful. People are making again career out of it. People are working at different levels as inspector, auditors, and whatnot. We as the end users, as the designers, we deploy it right at the process level pay, designing level pay, and then deploy it to the production, so that even our even if a third-party manufacturer EMS, which is outside the SE campus, is able to follow it religiously. So we know what is happening at his place, and we are able to safeguard the entire zone, yet maintain the IP of it. So we don't leak out information which will hurt us in any way. So that is also very important. So IP protection is altogether different topic, which I don't want to mix it with this topic what we have today in IoT. So IoT, what I covered now is what are the different levels of devices that we have, with different layers that we have, and what are the critical requirements of those layers. I gave you a few examples of connected device. I gave you a few examples of edge devices. I gave you a few examples of compliances for cybersecurity. Do you want me to stop here and take questions, or you want me to continue further?
Veena. Yes, participants. Any question?
I know it's a very tough time to. Okay, so I'll continue. I'll have another 15-20 minutes of presentation, then I'll open the forum for discussion.
Okay, okay.
I hope no questions means either you have understood everything or sub bouncer. Okay, either way, I'm available for resolving any of your queries or of any assistance if I can be to you. So from designing to manufacturing, now we are moving on. So let's look at different aspects that the manufacturing really wants you to have. Automation and digitization are achieved through different solutions. The end result of these initiatives are business benefits in form of improvement in productivity, in quality, in cost. Also, safety is very important aspect where unsafe environment could lead to accidents. So those accidents are to be avoided. For that purpose, also people go for automation. to increase the delivery to the customer, and also to boost the morale is what we really look at the automation. Just imagine you're empowering the worker to deliver better and more through this automation. You're giving more power to the workforce, that you are able to give more throughput, improve the quality, at the same time achieve the business goals. So the solutions are the special purpose machine for assembly process and inspection of jobs. Then you have use of factory automated robots. We use a lot of robots, but we use low end robots, not the high end robots that you see in automobile industry. We use to a level where we are able to deploy it effectively and get benefit out of it. So suppose if I'm able to utilize a SCARA robot and increase the productivity to a level where meets my monthly requirement, I'm happy with it. So a level further, it should be able to scale up, but not the way we talked about in automotive industries, where they talk about using robots in each and every zone. I'll explain that in subsequent slides. Though not expert in it, but I'll try to cover those aspects also. We also look at new process and technology to do better things. So even a simple automation like a drilling machine, where it is very manual and monotonous job, you can automate it without adding any cost to it. And a lot of innovations have happened from our entry level people also. I could see a lot of ideas coming from GETs who just passed out from college and very energetic and enthusiastic about automating it. They came up with very innovative ways by creating a just linkage and adding pneumatic switches can automate things. Really makes people happy about it. You don't have to deploy to high-end PLCs and the SCADA systems to do such a simple things. So thanks to the innovations there also. Complete line automation with end-to-end lean manufacturing facility by intelligent workbenches, POKA-OK, and manufacturing system effectiveness, what we are looking at now. So digitization of manufacturing business process is very, very important. So it frees up the energy not only in terms of from that particular task, but also to do much more from the limited resources that we have. I don't know how do I stop this. I hope you're able to see the entire screen. This is one such example where we have deployed the automation for switch, where the monthly production capacity has gone up to 40 parts per minute. Even the glue dispensing, the greasing, the pin connection, everything has become automated. Just imagine earlier we used to have people sitting on floors and then adding the pin, closing it. Sometimes they would forget it. Sometimes they would have a lot of rejections happening. So we have end-to-end solution now available. Auto feeding to integration, even for testing that happens, is completely automated. I'll just run the video. I hope you're able to see it. There's a dispatch that is happening. These are the feeder line that you see. It was taken long back. I mean, sorry for the old data because of privacy. Here you will see the pin dispensing, the pin that goes inside. The glue and then pinning. Yeah, here you see over here. I'll move on to the other side and show you from the testing point of view how does it look like also later. Even for the palleting that you have it automation. So after the testing is done, the palletization is also completely automated now. this was the initial time when we were trying. I mean, sorry about the backend mess. I think we're good to go. So in short, it's not about using the robot effectively. It's about getting the consistency out at the output, and making it more dynamic, so that even if there is a load of 200x, you're able to manage it. This is another example that you see where you have a completely automated system where you have input as a raw copper bar, and then you are bending and then tapping and the countersunk that happens, which was earlier done manually. So one person used to put it for bending, then remove it, and then put it for second bending, third bending, and so on. Now from one side you put the copper bar, and the other side you have the finalized bar that is coming out. Um, it's progressive tool that you see over here. One after another keeps on moving it, and then from other side you see the component coming out. Sorry, 1 second. I just accidentally closed my. Are you able to see my slides?
No, sir.
No, sir.
Actually, it's accidentally closed. 1 second. I don't know what happened. It just got closed.
Now it's visible, sir.
Yeah, now it's visible. Okay. Yeah, this is what we were slide number 29. Yeah, sorry about the lapse. So this was the example where you use automation for terminals and for MCBs and ACLCBs that we use. And the entire data is, we are able to live monitor the production, how much production that has happened, any breakdown that you see in it. This is what I was talking about. The link chamfering that was done manually has become automated using a simple pneumatic and hydraulic machines. So the hand movement of operations to bring down the drill bit is automated. A simple cylinder. This ensures the safety of the operator, and most important, improves productivity. So the monotonous job is removed. The high-end sophistication is not what we always target. We provide solutions that incremental benefit at low cost. Also, the frugal innovation that we are looking at, that is what really very important. Now I'll just take you through some of the SCARA robots, which are used for riveting, magnetic testing, and the oiling. May not be completely, I don't know whether you will be able to see this. The magnets, the piloting that you see over here. The machine tending that you have it, and then integration test bench. The entire operations are able to do complex algorithm testing, and then make use of the available past data. So ARM tool designing for quicker operations, and then we use robots for faster processes. This what helps in not only productive improvement but also man-minute reduction. We have a lot of touchless operations. We have safety as one key aspect, and then we are able to utilize the asset beyond our expectations and much more. This is what sorry, I just skipped a bit earlier. Yeah, this is one where you have pick and place, and then testing that is happening. You see the testing that is happening over there, and then after the test is passed, you put it elsewhere. So you're able to complete the test and then put it in the proper bin. This is one small robot that we deployed it for creating a dual grippers laser marking also. For fasteners that we have, I couldn't put the actual video because of the size constraint. Otherwise, I would have shown that. So in the end, what we saw was the evolution that we had. We could able to utilize those 20 man per month somewhere else. We were able to reduce the touch points, which was earlier required at different locations. And then, the kind of improvement that we saw in manual intervention elimination was phenomenal. And also the accidents which were happening because of droppage, because of spillage was reduced. The material movement between different stations were drastically reduced. On one station itself, you were able to do multitask. On top of it, the traceability was really good, not only in terms of local shop floor, even at SAP level, we were able to trace it beautifully. This is what I was talking about. Not the entire line gets automated. It's only the critical functions which we felt needs to be done. We are doing it. So you talk about riveting process, you talk about heating and oiling process, and the palletization of those magnets. These magnets are really heart of the contactors. Anything that goes wrong with the contactor can ultimately lead to failure of the contactors. So this has to be done properly. The riveting that we do, and then the treatment that we do on those components. So this is what we are one example that we are showing here. This is one more example for RCCB, where we were able to reduce the man minutes. Also, we were able to do laser marking. Earlier, we used to do pad printing. Pad printing was used to have a lot of drying time, pad maintenance. Laser printing has a lot of advantages. We are able to on the fly modify the lines and deploy it for different manufacturing, and then test it. So this was one very, very beautifully done and at low cost. Of course, I mean, we are talking about automation, but yet maintaining the overall cost ROI to the limitations. Yeah, conveyor belts. So the system, what you see over here, is, can take up to 120 different templates you can create. Just imagine 120 different products that you can manufacture on the one line itself, which was earlier not possible. We had to put one line for one, and then modify something, and then use the same for it. So there was a downtime for switching from one line to other line. Now that downtime is virtually zero. So you start manufacturing it. By the end of the line, you know what has been done and how do you deploy it. I'll take further. Yeah, this is, you see this MCBs of different colors. Even the color coding we are able to identify properly. So if it's a blue color, we follow a different treatment process. If it's orange color, we follow different treatment. It's only to create different cat numbers. We have Exora and Tripper of different ranges. One is for premium and one is for economy market. So different characteristics goes into it. So the robot is able to identify the two and then use it. It only not helps the manufacturing, but also helps the entire business processes to evolve better. So like a demand coming from a customer, feeding that happens in the SAP, how do you take on the segregation of it and then create a business manufacturing requirement and then activate those lines for manufacturing on priority is what also we do it. So the entire process, right from order coming in to line feeding to manufacturing to creating the component, depositing it into FG and creating GRN. GRN is good receipt note. Finally, that component has been manufactured, gets linked to the SAP. So we are not only talking about manufacturing, we are also talking about the entire ecosystem, which is automated. This is a big challenge. Those sound so simple, creating the SAP components and then creating a patch between the two OPCs we call it has to be really effectively utilized. Just an extension of it on what levels that we talk about, the scheduling that we worked on, the barcode printing that we worked on. We worked on different lines implementation. We had one Omega ACBs, then we moved on to MCCBs. Now we are working even on RCCBs. The database that we looked at, we even tried to go as general as possible. So SQL servers that we deployed, the barcode printing, we try to use the existing components as it is. The barcode scanning that we had, just add digital to it. So the data extraction becomes very easy, and we are not completely revamping everything. We are using a level on top of whatever existing system is, yet making it more effective. Dashboard that you see for every month on month, you are able to see how many components got made, what printing was done, how the scheduling was there, how many failures that we had, how many are still there on shop floor in semi-finished form, how many are there in finished form, how many can be sent to warehouse, how many has to be recalled back. Everything you get in one simple snapshot. Even the barcode scanning that happens is completely automated now. Not only to manufacturing, also to production plant manager, we are able to show what schedule was there and what actually deployment that happens, and what was the lag, and why the lag happened, and how do we overcome that lag. So a simple dashboard that talks about month-wise schedule and the adherence that we wanted to have. So if in terms of percentage we wanted to achieve 40%, are we achieving 40% month on month or not? Or so on. So whatever target that you set has to be completely followed. And if there is a delay, it sets the alarm right there and there. So you don't have to wait for the entire month and analyze the data. You're able to see the data update happens on the fly. So if a product gets manufactured, the data gets populated, the person is able to view it, and the corrective action is been taken. So not only the manufacturing and the ecosystem, even for quality, if they want to analyze the failures, they're able to use the same system and get the DPM output and create a Pareto out of it. So earlier, what we used to do it manual register entry. We used to have supervisors writing in Excel and then generating an Excel report month on month, and then you have delayed report coming. You have a wrong entry that is happening. Everything has been avoided now. Everything is available online for you. You plot the DPM. You see what levels that you have achieved. You can work on creating smaller Sigma projects where you can work on failures and then root cause analysis and then come up with a better solution for end customers. Quality. So this is how we improve our quality as well. So not only design, manufacturing, testing, system adherence, also quality level where people have gone to analyzing data and then creating certain quality circles. This is what I have overall to share with you. I open the forum now for Q&As or any specific applications or any requirement that you have, we can discuss, or any slide that you want me to revisit and discuss. I'm okay with it. Sorry for my bad throat. I mean, really not gripping well. I hope even if you are able to follow 20% of whatever I said, I'll be very happy about it. Because I understand you guys are working on at the bottom level of implementation. The application and usage of it is what something creates a linkage between the industry and the academics. Is what I would like to bridge the gap between. So what I talked about is design level, where you create 3 levels of architectures. At implementation level, you have cybersecurity compliance, then your manufacturing, you have robots and automations and quality controls. You have it. Anything what you talk about, take it and get a deep dive of it. I'm sure you'll hit something really very useful and informative. I open the forum for further discussions or anything that we'd like to do. Or any topic that you want to discuss further.
Sir, there are some questions in the chat box.
Okay. How do I view the chat box? Yeah, I can see that. In this period of pandemic, how will you use the process of automation? Initially, yes, we need to have some manpower to make it semi-automatic. But the moment you go on deploying it in the full scale, even for remote powering on off, you don't require manpower anymore. So I can give you one example where I had one line where we wanted to switch on for certain manufacturing process during this pandemic, during this peak pandemic where the labors were limited to 10% of the capacity. We were able to run in a good capacity for during that time also. So you don't completely jump from manual to automated. You jump to manual to semi-automated, where you have control of electrical parameters and a process flow. Then you jump to automated, where you even control those. That's why I said in my earlier slide, metering, remote monitoring, and control is becoming very key parameters now. I hope I answered that question to you. It was by Purnima, I suppose. Yes. So switching on, switching off is not something which has become very difficult now. Yeah, digital twinning yesterday. It is a huge application coming up, digital twins, I would say. You talk about digital twin is not only in terms of a subcomponent of it. The entire panel is being replicated into digital domain. I can give you one example. I cannot disclose what we are working on now today, but there is a trend where you see. So just imagine a customer who wants to add one MCB or one component into the panel. He wants to see how effectively it will help in terms of increasing the production, or how much load he's going to add to the line, or how much is the effect on my electrical systems, or how much is it going to hurt my carbon saving footprints. He's able to simulate it right there in digital domain and then bring it to the real world. Vice versa. I am ahead of time now. I know my load is this, my current is this, my temperature is this. This is what my wear and tear that is happening in my motor or in my panel. 2 months down the line, this is what my status is going to be. I can predict it. I can do proactive actions by creating these digital twin models. So there is no limitation to models that you can create. It's only thing, how do you link it in a better and efficient way? So use of MATLAB, use of ANSYS, all welcome. But you should have your own model which leads to actually applications. I mean, just not it's a motor, that means it cannot sustain 50 degrees, 60 degrees. It all depends on how you are using it also. So if I use it for shorter time of 10 millisecond, 50 millisecond for inching load, I can sustain it for longer time. So like, for example, I can give you a electronic component like MOV. MO is supposed to be rated for a certain value. And if you have surges, it can sustain surges for some period of time, number of operations. But if you subject it to more, the life reduces. So likewise, you can create a life model and then take a call on it. How do you want to actually deploy it to an application where you will be very much helpful there, rather than making it generalized across all. Please don't do that. That's not going to work. Yeah, sure. Thank you. But I'll tell you, simulation is something which is really very helpful. Of all the development that we do, simulation, modeling, creation, and deploying it on the servers is becoming very, very popular now. So if you're able to create one model, you have it. You can patent it, and you can talk to industries for use of it.
Any other questions, participants?
I hope I did not go too fast to cover the topic, because my sense was to cover from manufacturing to process, and also to understand what is the future trend that you see. So like I talked about, cybersecurity is something which people really should focus on. In manufacturing, it is becoming very, very challenging.
Sir, one more question in the chat box. To start
What
with,
in particularly cloud you want to? Samir has asked cloud. See, cloud is something which is pseudo server. You can start using it from ThingWorks, or you can start using from Amazon. It all learning will not take much time. What actually you want to use, make use of this cloud is really very important. You want to have only data available to cloud, or you want to actually make use of this cloud and make analysis out of it, and then on top of it you write your application and then do something from it, is what something you should look at. So infrastructure for hyperscalers like Amazon and Google can give you n number of platforms. They can even set up the system for you. It's up to you to deploy it and make effective use of it. Like for example, in home automation, you simply buy a switch and then make it automated using this Alexa. So that is something where the data goes to the cloud, and from cloud you are able to bring back data to effective utilization. So my sense would be, you can start with Amazon, Azure, whatever you like it. I don't know a relatively cheaper version of it, because in industry we follow certain norms for deployment into the application, because we use it for commercial purpose against you who use it for academic purpose. I think we should all work on even connected devices, because I see a lot of scope coming up in terms of having multi-protocol interfaces, like one device is having wireless interface with the same device. If I want to just tweak a bit and make it wired communication, it can be of immense use, because today 95% of the application in industry are wired. 5% also or less is wireless. For only reason is because of cybersecurity compliance. Bluetooth not good. Zigbee partly. You have it Wi-Fi, absolutely disaster in terms of industrial communication. So if you can make such things robust, you have a lot of scope there. So I think going forward, you and to your students, more and more application level pay for including this protocol should be one domain of understanding, which will be really very helpful for us to take it further from there. So because right now I see a lot of engineers coming to us with only a base knowledge of TCP. They don't know how does it work, but actually they know what actually only what it is. But the industry has evolved further. TCP is something which is bottom layer now. Now, on top of it, now we are talking about IC 64850, which is great connected communication, goose messaging, which is of the order of 4 to 5 milliseconds. You are able to deploy it on communications from end devices to central system to back to end devices. That's where the effectiveness will be very much helpful in terms of latency. What I just mentioned about, two people talking on phone. It's not about deploying it for the sake of only up network. It's actually making it useful, and collision division and collision avoidance is taken care. And I tell you, a lot of US is working on making system more and more robust, not more and more faster. Is what the so the payload has to be better and better. If I'm able to deploy more of a payload to customer for data, is more beneficial than increasing the overheads for the customers to communicate, and then saying my system communicates at 100 Mbps or 1 Gbps. That's not going to help. So you have one side coming lighter and lighter protocols coming in terms of NB-IoT, where you have limitation of speed. At the other side, you're talking about giga speed data, but you have other challenges. So somewhere you have to optimize in between. So LoRa is coming up, and I can count on any number of protocols, but getting an expertise on those protocols is also very important. Okay. Any other question?
So what are the research areas in IoT and cybersecurity?
Like I said, IoT, you have a lot of simulations that you can create for the model. For example, majority of the learnings has gone into motor management and control. Very less time devotion has happened to other components of industries. For example, circuit breakers, panels, bus bars, trunking systems. You have solar panels. You have drives. All those things require a good amount of attention, which actually will require is application and use case. That is one part of it in industry domain. In terms of cybersecurity, what I see is the world has just started now, understanding how to work. There is sky is the open limit for it. So one example where I can talk about is creating a encrypted key and deploying it for low-end application is becoming very, very popular now. So for example, if you have a switch and if you want to upgrade the switch, a home switch or a touch switch, which you must have seen in high-end residential application. So a touch switch, if you want to upgrade it for some different application, you have to deploy some code to it. How do you ensure that the code doesn't get corrupt and then the switch becomes useless to you? So either you upgrade it to right version or you don't upgrade it, is what we are looking at now. So cybersecurity comes very handy in that sense. Firmware over the air is becoming very, very popular now. So wirelessly you are able to deploy it everywhere. So you see mobile phones being upgraded. How does it happen? How do you use it into industry domain is what something we are looking at now. But of course, safety is most important. So it should not happen. Someone is working in front of the panel, and all of a sudden the software upgrades and starts functioning in different form and what he was not anticipating. So you will have to have close connection with even the actual usage of the product to upgrades and the future deployment. So we have one product called MPZ. You must have heard about the name, where we use a lot of safety features to upgrade the firmware yet maintain the sacrosanct of the product. Let's not deviate from the basic functionality. The basic functionality of the product has to be there. You add wrappers around it to make it more robust. This is what we should look at. So one person working on the basic code function, one person working on adding wrappers to it or communication, one person working on multi-language communication is what something we can all look at. Because I am sure no industries will come to common conclusion of one protocol. That's not something going to happen. From application to application, it's going to sustain, and we see lot more and more wireless technologies to evolve further. You have 4G, 5G, You have short range communication, sub gigahertz, and so on. So for domestic application, I see sub gigahertz becoming very popular. For industrial application, sub gigahertz plus 2.4 gigahertz plus 5 gigahertz becoming very popular, and so on. And so, I mean, someone has to study the technology trends and start creating use cases. May not be applicable today, but may be useful tomorrow. I like that Arduino board. Huh? I mean, every time in a discussion, people could just talk about Arduino board, Arduino board. I mean, people are getting used to some sort of embedded understanding. So that's a very good part. So I mean, knowing a coding is not a great thing. It's something which was being looked at 5 years, 10 years earlier as wow feature. Now it has become a person joining an organization should know coding. And thanks to you guys who have made the future generation very suitable for ready to use the technology right from day one. So using Arduino to write the way and adding sensors to it and adding on top of it the application to it will make it very, very useful. Not only in terms of understanding, also in terms of future mindset. How do I going to use the technology?
Yes, participants, any other questions?
We also undertake engineers for our internship projects. Huh? If someone is really interested, we are open for it. So you can approach me or you can approach HR, and you can align it where we really give live projects to students who are really deserving, and we ensure that we get things done out of it. So that is also one good forum that you can actually get hands-on. I don't know whether it's feasible for you guys in during this pandemic or not, but yeah, we can do that also.
Okay, sir. Such a wonderful session. Thank you, sir, for this knowledgeable session. The PowerPoint presentation was really informative, and videos of real-time applications of IoT in industries made it more interesting. In very short span of time, sir have given glimpse of entire IoT industry. We understood industry trends, different IoT products, their manufacturing units, evolution in robotics, and overall growth opportunities in the field of industrial IoT. So we are really grateful for giving us your time despite your poor health. Thank you very much, sir.
Yes, thank you so much. You want me to flash my email ID here? I can do that.
Yes, sir, you can write down in the chat box or on your PPT slide.
You can reach out to me at this email ID. So thank you for your time. Thank you for listening to me. And during this lunch hour time, I know it's very difficult to be awake. I'm available at all your queries and disposal, not only in this forum but later on also, because I expect a lot of from you. You are the guys who form a building block for us to move further. The kind of papers that I see, technical papers and articles coming from the colleges and students, I'm very impressed. I hope we continue the rapport and be in touch.
Yes, thank you.
Thank you. Thank you.
Now we will have a short tea break of 15 minutes and resume FDP program at 3:15 p.m. Gentle reminder to fill the attendance cum feedback form, and the link is shared in the chat box. The link will be active for the next 1 hour. Thank you, everyone. Good afternoon, everyone. On behalf of Electronics and Telecommunication Department of AP Shah Institute of Technology, I welcome back all the participants to FDP on IoT, a journey from sensor to server. Before we begin with the next session, there is a small announcement regarding tomorrow's evening session on Learn the Way of Life by Ms. Darshana Jain. The workshop is going to be fun-filled and highly interactive as you will see and perform exciting experiments done on humans from which they discover the truth about themselves. It's going to be an enlightening journey of self-discovery. Participants are requested to bring earphone, pen, paper, blank paper and colors for the tomorrow's session. So hoping to see you all with a lot of curiosity for this activity-based session. Now let's move for today's last session on the topic of demonstration of IoT implementation. Let me introduce to the speaker for this session, Mr. Selvin Furtado. My colleague, Assistant Professor at AP Shah Institute of Technology, Thane, affiliated to University of Mumbai. Sir is MTech in Telecommunication Systems Engineering from IIT Kharagpur and was awarded MHRD scholarship for entire course. He is in charge for Texas Instruments Innovation Center at APSIT. He is a team leader in faculty team for task-based training eYantra and IIT Bombay initiative. He is a project guide for India Innovation Challenge Design Competition IICDC and eYantra Ideas Competition EYIC. Sir is also providing consultancy to many industries like ANOVA Solutions, Deep Electronics, Acknowledge Engineering Solutions, Dictation Devices. Sir is also into syllabus revision committee, guest judge for different competitions, delivers expert talks, trainer for FDP programs, workshops, project-based learning, and many more. I would like to invite Selvin sir for the session on demonstration of IoT implementation. Over to you, sir.
Thank you, madam, for the introduction. Good evening, everyone. I welcome you to session number 12 of ATAL sponsored FDP on IoT, a journey from sensor to server. In today's session, we'll be looking at a demonstration of an IoT or a complete implementation of an IoT. Okay. Let me begin by sharing my screen. So is the screen visible? You see the first slide?
Yes, sir.
All right. So I'll give you a brief overview of what exactly I'm going to do in this entire session. So we'll begin by understanding a typical IoT monitoring system. Okay. We'll select a specific example after that, and we'll design and implement for that selected example. In the process of implementation, we'll be using MySQL, PHP, HTTP, and will build on Arduino for ESP32. If you wish to follow along, you could download and install XAMPP server and Postman and any HTML editor of your choice, maybe VS Code, Notepad++. It's optional if you prefer to follow along. It's not mandatory. It's your choice. Okay. That being said, let me give you an example of a typical IoT system. So on the screen, Just a minute. All right. So on the right side, I have here is a typical. Sorry. It's a typical greenhouse. Okay. In this greenhouse, or rather, greenhouse is a controlled climatic environment for growing plants. So here, heat, soil moisture, ventilation, and humidity are primarily controlled. So in a greenhouse, there are 4 parameters that are monitored and controlled: heat, soil moisture, ventilation, and humidity. So typically, to control or monitor these 4 parameters, we'll have 4 sensors. So we'll have 4 sensors to monitor these 4 parameters. Now I would love to look at these parameters remotely or monitor these parameters remotely. If I want to monitor it remotely, these parameters have to be sent over internet and have to be stored on a cloud. So cloud essentially means a server with some kind of a database. Internet and saved on over here. Once it is saved here, I could access it through any of my handheld device or maybe a computer and so on. Okay. Now consider a scenario wherein the soil moisture drops. Okay. So while I'm monitoring, I notice that the soil moisture drops. So I would like to have a facility to turn on a water pump. Okay. And it will water or increase the soil moisture or give water the plants rather. So in order to control this valve, I need some kind of an actuator. Okay. So monitoring and control, sensors and actuators, sensor to monitor, actuator control. So by clicking on a button here, maybe it will send a command through the cloud to the actuator. Okay, and that will turn on this pump. Okay, so this is how a typical IoT system looks like. Let us now select an example. So on the screen, you see a wide array, or rather one of the classifications of IoT. So it is broadly classified as customer facing or business facing. For example, maybe Apple Watch, right? So Apple selling customers Apple Watch is a customer facing. They're directly dealing with the customers. On the other hand, if a company provides BMS services to a mall or a hotel per se, then that would be a business facing. So it is business is providing a service to another business, so business facing. But typically, I always prefer working with on the business facing front. So let me let me select monitoring in health, health monitoring. Okay. So this is the example that I selected. Now let us select, let me decide which systems to monitor. Okay, what to monitor rather. So on the screen you have a server room. So the reason why I picked server room, because this is an ongoing in-house project. So we are in the process of setting up an IoT system to monitor server room. Okay, the health of the server room. So when I say health of a server room, primarily health means the temperature, the humidity, and the closed access or access to the server room. Temperature, because servers usually require some optimal temperature to operate. So most server rooms, data centers are air conditioned, and the temperature is capped at around 23 degrees Celsius. Humidity should be as low as possible. Of course, because these are all electronic equipments, and to ensure long life, it should be the humidity should be as low as possible. And finally, closed access. Nobody should be able to just walk into a server room and meddle with it, right? So the moment the door to the server room is opened, there should be some kind of a trigger or some kind of a notification. Hmm? So these are the three parameters that are to be monitored in a server room. Now we'll look at a typical monitoring architecture. So in yesterday's session, you saw a couple of temperature nodes, right? Temperature humidity measuring nodes. So in yesterday's evening session, Pavaskar showed you a node. Node means a microcontroller connected to a sensor and connected to some kind of a communication module. So in yesterday's session, it was a temperature humidity sensor, and microcontroller was Arduino Nano, and radio interface was NRA. So these are four such sensors or four such nodes. These are four such nodes. All right. And these nodes would be communicating with a node called as a sync node. Okay. These would be communicating with sync node. All right. The kind of link between the two would be long range, low power, and low bandwidth. Any thoughts why this is required to be low powered? Any ideas? So I'll talk about a scenario. Okay, imagine a data center or maybe a warehouse, a cold storage warehouse, where you're supposed to install like 200 temperature sensors. Now, if I were to have high power, so high power would essentially relate to wall powered devices. So high power transmission requires wall power because the battery would quickly drain out and it would be a burden to keep changing battery every week. All right. So high powered wall powered devices, let's say 200 of those, if I were to lay out in a data center, the wiring itself would be a huge task. Electrical wiring, providing sockets, buttons, and so on. And God forbid one of the buttons starts malfunctioning and so on, it would be quite a burden. On the other hand, if I were to have it as a battery powered devices, I just walk to a location, I place the sensor, I program it to report the location, and that's it, right? So from a deployment point of view, having battery powered devices is a huge bonus. And when you talk about battery powered devices, it has to be low powered devices, right? It has to be low powered devices so that the battery life lasts forever, and not forever, as long as possible. Now the sync node, moving on to the sync node communicates with the server. Okay. The link between the sync node and the server is usually a high power link or high power link in order to save
Sir, your
on.
voice is
Yes.
sir, voice is breaking in between.
Acha. Does it help now? Is it better?
Yes, yes.
Yes, sir.
Thank you. So, so low powered, and in order to save on battery, we have low bandwidth. Okay, and essentially we'll be just transmitting one temperature or humidity values. So low bandwidth is good. But when we talk about the sync node, it requires higher bandwidth because it is going to sum up all this data, collect it together in one go. Okay, so high bandwidth is preferred. So sync node essentially is going to have two communication interfaces, one with the nodes and one with the server. Okay, and server as it is something like a computer which is equipped with uh, a landing page for the data that is being sent by the sync node. Now, this is a typical monitoring architecture. Now, I'll like to focus on the server room monitoring architecture that I'll be discussing today. The only difference here is that instead of having a node, I'll be directly connecting a sensor to the sync node. Okay. So the only difference here is that instead of having an array of nodes communicating wirelessly or wiredly to the sync node and sync node aggregating the data, I'm going to have the sensor directly connected to the sync node, and rest everything remains the same. The reason why I'm doing this is because this would be my primary focus of today's session. The previous part, okay, this one, this part was already covered yesterday, right? This part was already covered in session 9, right? So we'll focus on this part now, the sync node to the server link. All right. Now, this being said, let me start selecting the components. So here on the in the diagram, you can see these are the various criteria or various things that I have to select for designing a system. So we'll have to start with devices, network protocols. And the diagram here states data analysis as one of the components, or rather the core components of IoT. However, data analysis itself is a huge topic on its own. So I'll not be touching data analysis. We'll be limiting ourselves to platforms only, maybe some other time. So let me start with the devices. So the device I select is ESP32. So I'll show you an ESP32. So this is an ESP32. Okay. I'll justify my choices in a bit. Because I'm selecting an ESP32, the network that I select would be Wi-Fi because it comes with an onboard Wi-Fi stack. Okay, so Wi-Fi selecting would be a logical choice. Protocol, I'll select REST. Now, when you talk about IoT, MQTT pops into your head. So IoT and MQTT are sort of synonymous words. However, the reason why I select REST API, I'll justify it in a bit. And finally, a database. So that's it. Okay, so we selected a database, REST API. We selected Wi-Fi, and we selected ESP32. We are not penetrating, going on to the core layer of data analysis. All right, we are limiting ourselves to platform. Now let me start justifying my choices. Mute Zale. So let me start justifying my choices. So device is ESP32. So it's a very beautiful image that I picked up from their website, expressive website. So it has a robust design capable of operating from minus 40 degrees Celsius to plus 125 degrees Celsius, and powered by extensively pre-calibrated circuits and so on. So robust design in all. Ultra low power consumption. So not exactly as compared to XLP processors, But when you have Wi-Fi on board, a Wi-Fi stack on board, so when you already have a Wi-Fi stack on board, so having a power of around consuming a power of around around, let's say, even if it is 100 Mbps, 100 milliamperes is quite low power from a Wi-Fi point of view. Okay, and so I keep getting, yeah. High level of integration. Imagine this entire small thing capable of a touch capable inbuilt sensor, temperature sensor, Wi-Fi stack, a Bluetooth stack, 4 megabytes of flash memory, and so on. So it's extremely high level of integration. And of course, hybrid Wi-Fi and Bluetooth chip. Okay, so that is my obvious choice. And most importantly, I had one lying around handy. So just a minute. Okay, so and I had one hand lying around quite handy. So if you when you actually sit into design stuff, a lot of the times your selection of the modules or components is driven by the availability rather than the requirement. So this was quite available handy, so I picked it up. It comes as a development board costing around $500. It's quite cheap as well. So moving on to the next obvious selection, that was Wi-Fi. So here on Wi-Fi, I have selected, I've written down a couple of advantages and disadvantages. So nothing big, just to read through. I selected Wi-Fi because it comes in as a part and parcel. So Wi-Fi is a sufficiently high bandwidth, it has sufficiently large range, and it is easier to connect to the internet on through Wi-Fi. So Wi-Fi. Now, when you talk about Wi-Fi, communicating with the internet or the access point is sort of a 7-step process. But Arduino to our rescue, it is completed in under 7 lines. All right. So this is something I really love about Arduino. You just pick up a code, paste it there, and it works out of the box. So engineer does not has to dive down to the driver level to tweak with this thing, drivers or whatever the firmware. Now let me justify my protocol selection as REST API. So I told you, right, IoT is synonymous with MQTT. However, on the screen, I have taken a screenshot from EMQX Cloud, which provides MQTT this thing, MQTT service online. Okay, I have marked the annual prepaid payment required. It comes out to be $1,340. That's close to 8.5 lakhs. I don't know about you, but it is too expensive for my taste. On the other hand, if you look at a cPanel based web hosting that comes with REST API capabilities, for $3,823, you can get it for 3 years. So that is practically $1,300 per year, close to or just about $100 per month. Okay, that's including taxes. So the REST API is justified. Now let us look at the REST API that we'll be using. So these are the 4 common most popular APIs: get, post, put, and delete. We'll be limiting ourselves to get and post only. Will not use put and delete. So essentially, get is a process of fetching resources from the server. It is read-only method, but you can tweak it. बोलते हैं Indian जुगाड़. So with जुगाड़, you can tweak it to create new resources as well. But it is not recommended to do so. To create new resources like entering data into database, always advisable to use a post request. All right. So platform I'm using XAMPP. XAMPP is a parcel of Apache, MySQL, Tomcat, and so on. So there's FileZilla as well. The reason why I choose this to choose Apache is because it is open source and free even for commercial use. So tomorrow, if you want to set up a server room monitoring system at your college, you could just copy my code and still use it for free, and provided you own your own server. So because you have a server room, so essentially I'm assuming you have your own server. So it is practically free. And I selected MySQL because it is cross-platform and it is supported. It supports quite a few languages and so on. Okay. All right. So MySQL is not a very trending database. It has a bit of a problem when it talk about from a big data point of view. But when you're starting out, it is important to get things running. All right. In order before getting them exactly correct, it is more than sufficient to get them running. So it boosts your confidence. So therefore MySQL. This is the sequence that we'll be following. We'll first set up a MySQL database. We'll design a few PHP pages. We'll create a landing page for IoT device, and we'll then finally program an ESP32. Okay. Okay. So let me switch over to new screen now. Okay, give me a minute. So begin by sharing my screen first. All right. So we'll have to have XAMPP install, of course. So let me start my XAMPP server. So go to control panel and let's start the Apache server and the MySQL server. Yeah, these two are more than sufficient. We are not interested in Mercury, Tomcat, or FileZilla. Once we are in the MySQL server, I'll start with the admin. Okay, we'll begin by creating a new database. So let me call it ATAL FDP database. So I create a new database. Okay. Oh, I think I stopped sharing. Screen. All right. Okay, so let me call this my database. So once in database, you have to, once you have a database, you'll have to create some kind of a table. Okay, you have to create some kind of a table inside a database. So let me create a table. I'll call my table as server room. Okay, no. Just a minute. So I'll call it as server room. Okay, I'll need 7 columns. So you'll know what these 7 columns are in a bit. Okay, so server 7 columns. We'll start with ID. ID would be the first one. Let it be integer. Let the length be up to 6. Default, let the attribute be unsigned. I would like to add this as a primary key. Okay, and let it auto increment. All right. Next would be I'll call it as a mode. Okay, mode is a name given to a sensor plus a controller with some kind of a radio interface. It is called as a mode or a communication interface. So it's a mode. So the mode has to be a varchar. Let it be around 20 length. All right, and that's it, right? So not nothing more needed. Next, see, whenever you're talking about a mode, there has to be some location associated, right? So where is this mode placed? So let location again be a varchar of 20, right? Next, temperature. Temperature, of course, it is best to be a float. And when it is float, nothing else matters. And I'm going to allow it to be null as well. So there might be a case wherein, let's say my ESP or my mode does not have a temperature sensor, it only has a humidity sensor. It should still be able to send data to the same database. So I'll allow this value to be null. Next would be my humidity. Okay, again a float, and I'll allow this to be null as well. So when I mark this null, what it means is that even if I don't submit this value, okay, if I don't submit this value, still a database entry can be created. All right. Okay. Next was the door status. Okay, we discussed this, right? 3 parameters: temperature, humidity, and access control. So let me have door status. Let me be a Boolean number. Okay, and I'll allow this to be null as well. So what it means is that there might be a possibility that my sensor may not have one of all 3 capabilities. So I can have a mode wherein only it is capable of only sending one value, or it is equipped with a single sensor. And lastly, I'll require timestamps. Reading timestamp. All right. So timestamp is going to be timestamp somewhere here. Yes, timestamp. Okay, and let this be the current timestamp. So this is something that the server will add it on its own, and let it update on current times on update. Okay, so whenever this is updated, it will create this timestamp and will add to the system. So looks good. Let us execute the query, and so I have successfully created a database called server room inside my ATAL FDP database. Okay, now let's check if it actually works. So let me insert something into it. So ID is auto increment. I'll leave it as it is. Mode has to be, let me call it as ESP32. And location, I'll call it as some room number, let's say 422. Let float be 34.6. I know it's quite hot, and let's make it extremely humid. Okay. And let the door be not accessed. Okay. That's it. Let's execute this query. And yeah, let's see. So one row is inserted. Let's go back and check the server. So I see an entry here, right? So my database part is done. So I successfully created a database inside my MySQL. I successfully created a table inside my database in MySQL. Now let me just a minute. Now let me go ahead and create a set of web pages. So fetch docs, and let me create a new folder. Let me call it ATAL FDP. So you see an ATAL FDP test here. That was me testing out the stuff before presenting. Okay. So I'm inside this folder now, and let's see. I'll have to create a new file here. So let me open up VS Code. Visual Studio Code is my preferred editor, HTML editor. Okay. It's not that you have to use the exact same one. You could choose your own. Let me pull it up. All right. I suppose you are able to see extremely black color screen. So
Yes, sir.
Yes,
I
sir.
preferred it to be a darker background. I do a lot of coding, so it it's tiring to look at a bright screen. I preferred a dark background. All right. So I am inside my ATAL FDP folder. Okay, so it is quite easy. Okay, so I'm in my ATAL FDP folder. Let me create a new file. Let me call it as index.php. So I haven't added any code as such, or I'm just starting out. Okay, but I'm still calling it PHP because I'll be adding PHP code. Okay, so this creates a file. Let me see if it actually works. So let's see. PHP. All right. So let me echo something. So we'll do a hello world program, save it, and let's go back to our browser and check if it is visible. So localhost, ATAL FTP, and because I've named it as index, when I try to access this directory, it will directly give me take me over here. So hello world, right? So it works. So PHP is working, everything is good. All right. Okay. So we'll first create a display page. Let me create first a display page that will display data that is inside the database. Okay. So let me begin by having a doc type, and we'll have the HTML tags, and we'll start with the head tag. Inside the head, let me give it a title. So let me call it as a server room status. All right, saved. Let me go back to my browser, refresh. You'll observe it says server room status over here. I hope you are able to see that. It's on
Yes,
the
sir.
tab. Yeah. Okay. So if I were to remove this line, okay, and refresh, you'll see the directory or the path to this thing. When I add this, you'll see the tag. All right. Now, oops. Okay. Let's move on to the body now. See, I am using an autocomplete or IntelliSpace environment. So I type a couple of characters and it auto completes everything. So my IDE is understands me a lot. Okay, and it knows what I want to type, so it auto completes. So if you're lagging behind, do let me know. I'll copy and paste this stuff in the chat section. All right. So in the body, let me have an h1 tag. Let's call it as status logs. TA logs. So what it does is that it is going to remove this hello or put status logs over here in a sort of a heading sort of fashion. Now logs are usually preferred in a tabular form. So let's add a table now. So let's take this here. The rest of the things we'll do it in PHP itself. So it's not necessary, it's just convenient. All right. Okay. Let me begin by creating a table. Right. So this looks good. Okay, in my table, let me add let this be 5. All right, and I'll have a cell padding. So what I'm doing right now is just adding a bit of padding and spacing. This is based on my previous experiences. All right, you're free to try it on your own. Let's go on and add a table row. Sorry, wrong slash. Right, inside this table row, I'll have a table data cells. Okay, so the first data cell would be table data cell. First would be ID. So I would like to see the sequence number. So it will give me an idea as to how many samples are actually there in this thing. Let me quickly do this. Okay, let's have another one called as mode. So I'll know which mode I'm dealing with. Let's have location and temperature, humidity. I'll call it reading time. Okay. or timestamp, let's say. Okay, timestamp. Okay. Okay. So far so good. Let's check if it actually works. Are you able to see when I switch between tabs, right? So this is my coding environment and this is the web browser.
Yes, sir.
Yeah, thank you. So this is it, but it looks a bit small, right? So let me just add or increase the font size. I'll use the style. Do it for the entire body, that would be easier. Font size, let us make it to 30 pixels. See if it works. This looks good. 30 pixels is good. Okay. So now that our basic table is ready, let us fetch data from the database. Okay. So in order to fetch data from the database, we'll have to first form a connection to the database, right? So let me use connection. I'll use my SQLi. So my SQLi, see, it shows here. So it requires the host name, then the username. You see that in autocomplete, right? So host name, username, password, database, right? So that host name is just in reports, right? Local host, right? Then comes the username. Username would be root. It's the common one, the default one. I did not set any password, so, and my database name was ATAL FDP, right? That's it. Let me check if the connection was actually established. Okay, so if connection, if there was error, let's say connection error, there was a connection error. Let's go. Okay. And if it is all good, let's display all good. Right? Let's see if it works. All good. So see, because I'm okay, yeah, all good. Should add this after that one. That would be a better idea. See. Okay. All right. Okay. So now once the established connection is established, let's build from here. So I would like to get a couple of entries from my database. So let's head over to my database. See, I'll write to query the database. So when I go to the SQL, there's a pre-found queries here. So selecting is used to fetch data from server room. Okay, and instead of where, we'll first use order by ID. Let's do it in descending fashion. So I'll have the most recent entries first. So last entries would be on top. And let us limit to 5. Okay, let's have 10 entries for that matter. So this, let me check this query if it is executing properly. Yes, so success, and it is showing me the data, but as it is, I only have one entry in the database. It is only showing me one entry. Now here comes the shortcut part. So you just click here, create. If I'll just scroll in here. So create PHP code, click here, simply copy, come back here and paste. So now your SQL query is created. It's done. So it's easy this way, right? Fun. All right. So okay. So now that query is created, let us fire this query. Let us hold let us have result equal to connection query the SQL query. So far so good. Now while there's some data here, so let's have another one. We'll call it as a row, and this would be result ka fetch association, right? So while there are results inside this result, or while there are columns or rows inside the result, it will keep looping. And let me have it like this. We'll call it as T. Okay, so this is row ID, and row ID will fetch row bracket row may say ID. All right, and it would display this as well. Okay, I'll use the exact same thing here. Okay, and instead of having this as ID, I'll have it as this. I'll add dot dot. Let me add this here. Okay, looks good. Let's just check if it works. So it works. Huh? So ID 1 aa gaya idhar, right? So let's go back. Do it for the rest of them. So I've got ID. Next I'll need mode. So the same exact thing. So I'll have to call it as a mode, right? Mode, and this would also be mode. Sorry. For book, and this is location. Then would be temp, and this is temperature. Next would be humidity and reading time. So and let this be what was it?
Timestamp.
Yes, it was reading time. So camel paste. And call it as RT. Okay, so first was mode. So you'll see over the period of time, initially you'll have to type out a lot, but as you become proficient, it is mostly copy paste job. Let's see if this works. Yes, it works. A bit offset is not exactly correct, but it still works. Not a problem. So let's not focus there. We'll focus on if it works or not. Let's get it up and running. Okay, so this page is sort of done. But before I leave, it would be a wise idea to free up the resource and it is always good idea to close the connection. So all right, result freed, connection closed, and let's go back and check if it is still running. Yes, it is. All right. Okay, so now my display page is ready. I'll have to create a landing page for the data to be inserted into the database. So when this mode or ESP32 is sending data over from Wi-Fi, it has to reach the database and it has to be inserted. So exposing SQL database to the internet is not very good idea. So what I'll do is that I'll create another PHP page called as I'll call it as landing page, and I'll call this as server. I'll call it as server room.php, right? Okay. Get a few details from here first. Just give me 1 minute. Okay. So the usual, I'll copy a bit of code from here as well. So the connection part remains the same. Of course, before I connect it, actually, I'll have to add in the PHP tags, right? And it see. Saved. Let me go back to my browser and check if it page is working. I'll call it server homepage. Right. So no error. All good. So see, I'm not bothered about how this page looks on the browser because I'll not be using it through browser. Okay. So once the query or the database connection is created, let me create a few variables to enter. Okay. What I'll do now is that I have already created a page for this, and what I'll do is that I'll, instead of typing out the entire thing, I'll use this template and I'll walk you through the process of this thing, right? So it would be, I suppose it would be faster. We are a bit hard pressed for time. So this is a template that I'm using. It's a ready-made one. Okay. So let me walk you through the lines of code. So server name, database name, username, password. This these parameters are required to make the connection. Okay, make the connection to the database. The connection is done way over here. Okay. So now what happens is that the connection is not the first thing that you see. It's embedded deep inside the code somewhere in the middle. So it's like a close to 890 page code, and it is in line number 49. So it's middle. So it is always advisable to create variables and assign them values and use those variables at places. So if tomorrow, if I were to use this for some other, or if I were to pass on this code to you, you would be simply be able to change the name of the database and make it work in a single go. Okay. So that's the idea. API value is something that I'll explain in a bit. So I'll explain in a bit. For now, API value is just a variable with some random character array. Okay, so it's like a site of a password kind of thing. Okay, so I've created API key, mode, location, temperature, humidity, and door status. Which we didn't use door status there, but that's okay. And I've added a counter as a variable. So there are 3 new variables that you see: key value, API key value, then there is API key, and is counter. Rest these set of variables are quite self-explanatory. Now, remember I talked about there are multiple or 4 major methods of accessing REST API. four methods in REST API. So get, post, put, and delete. So get is used to fetch data from the server. So when I do this, okay, so when I'm doing this is fetching data from the database, right? This is a get request. Okay, get request is used to fetch read-only data. It does not modify or change anything. The reason why this is used for read-only is because it can be bookmarked. So I can bookmark this, okay, and I can save it. So I can go back to this place every single time. If a GET request were to create a resource on the server side, and if somebody bookmarks it and it gets auto-triggered, it will end up creating n number of resources on the server side. It will burden the server. So we always use post method, which cannot be bookmarked, and wherein the data is supplied in not in the body or in the URL, it is separately supplied. Okay, in the body of the this thing, apna package already, or the HTTP packet. Okay, so it is not sent in the URL; it is sent in the body. You cannot create a post request through your browser. So creating a post request through your browser is a bit difficult. That is why I had suggested you installed Postman. So Postman is an application that is used throughout the industry for testing APIs, for designing and testing APIs. So let me share my Postman screen as well. I hope you are able to see Postman.
Yes, sir.
Yeah, okay. So here, this is my location and I'm using a post request. See, there are n number of requests that you can make. These four are the most popular ones, and we'll stick to post to create new resources. Now, when we are creating a resources, we'll supply that information in the body of it. Okay, your choice. You can send it as a form, URL encoded forms, or nowadays people prefer JSON, right? But this is easier. Huh? URL encoded forms are quite easy, and they don't take up much, or the string does not. It's not unnecessarily long. It has just the amount of delimiters. So personally, if I were to choose, I would always choose URL encoded forms. But JSON is becoming the norm nowadays, right? So this is something that I've created, right? So these are the see, if you'll see side by side. So these are the exact number of keys that I or variables, and these variables are exactly the same now, right? Now, when I'm going inside this thing, I'll check if the request method is post. I'll first check if the request method is post. If it is post, I'll check if API key is available. If API key is provided inside this set of messages, then I'll check if the given API key that is provided here is exactly identical to the hard-coded one. Okay, so providing this API key is sort of a fail-safe, right? So usually this is a very trivial method of security, but still it is a simple way of securing your this thing web page from unauthorized access. So I'll show you. So let's say if I were to disable all these key values and I were to send a request, I would say unauthorized user failed. If I were to send a GET request, it will say that no data posted with this HTTP post. So I'll show you, right? So in if, at the end of this if, so if it is not equal to post, I'll echo this thing, no data posted with HTTP post. Well, let me change this. get not authorized. Use HTTP post. I'll show you. So get not authorized, use HTTP post, right? What happens is that, so if somebody tries to access this web page from a browser, this is what they'll get. Yeah.
లేదు వెళ్తా నేను అక్కడ నుంచి డైరెక్ట్ మళ్ళీ లేట్ అవుతుంది ఇంట్లో అంతా బట్టలు ఇట్లా పిండెత్తేది మషిన్ వేసిన నేను
Okay, so nobody will be able to access this from a browser. So that is one layer of security added. So nobody is going to accidentally add entries to your database. That being said, now let us switch over to post. Now, if somebody does not have this authorized key, okay, or if somebody doesn't know that you're using an API key, they'll say that user authentication failed. If they end up you having a wrong key, okay, it will still say wrong API key provided, right? So sort of a layer of authentication, right? So if it is not present, see if set does not have it API key, it will say user authentication failed, right? If API key is present but it does not match the key value, it will say wrong API key provided. All right. Now comes the rest of these parameters. So we'll check if each of these parameters are there. So if mode is present, is location is present, and so on. So let me add mode and try and send in a query. It says insufficient data, means I need some location and at least need one of the three values, at least one of them. Okay. So let me add location as well. Still insufficient data. I'll need at least one value. Let me add temperature, and yes, new record created. Let us go back to our database and check if actually it was created or not. Yeah, let me. So okay, just a minute. Supposed to test party. Let's see. Got successfully created. Let's refresh this, and voila, a record is successfully created. You'll see humidity and door sensor values are all 0. So okay, so these are not present. Okay. Okay. Or when I add all three values and send it, okay, all three values are present. Okay. Now door status is supposed to be, I set it as Boolean as 0 and 1, but you can use the counter, added counter, to show the number of minutes it was open. Like it was open and it was immediately closed, you can have that number there, like in minutes. Let's say it was open for 5 minutes. Okay, so one open and close is somebody coming in and leaving. So somebody left after 5 minutes, you can use that as here. Okay, or if it was simply open, you can use it as 1 here. Your call. So it is completely depend upon the requirement and your environment that you're dealing with. Okay, moving on. So in order to be able to state that amount of data is insufficient, I'm using counter variable here. So I initialize counter to 0, and then I go on adding stuff. Okay, go on adding stuff here, And at the end, if the counter value is greater than some predefined value, then and only then the record is created. If not, it says insufficient data. Okay. For creating this record, it's quite simple. Remember, we created this tested this, right? Okay, so insert. So I tried this, right? Mode was, let me have it as ABC. Location was DEF 34. Make it extremely hot, 67.5, and extremely dry, 12.8. The door status is still closed, and I execute this. So on execution, it gives me this insert into this thing. Okay, so I simply copy this, or you can see here, right? So this is a create PHP code as well. So you copy this full thing and you paste it here. The only difference being, if you'll see, these are hard-coded values now. See, A, B, C, D, E, F. Instead of that, you use those variables that we declared some time back. So the variables that we declared here and which hold the data that is received in post request here. Okay. We insert it over here. Okay. And if the query was successfully executed, then we say, okay, new record was created. If not, we say that this was the error kind of thing. All right. All good till this point. Okay. Let's save this, and I'll now move on to the hardware part of it. Okay. So I'll move on to the hardware part. Let me find Arduino. Okay. So here we go. So what I've done is that I picked up a random sample from my from the examples and I'm using that, right? I hope this font and everything is visible to you all. I'm
Yes, sir.
big fan of dark environment, so everything on my screen is usually dark. Okay. Now for the URL, see here when I was dealing with the URL, I wrote it as a local host, right? Because the database, the web server, the browser, everything is on the same machine. But when you're trying to access it through a different machine on the LAN, you'll require its IP address. Okay. To get the IP address, what you do is open the command prompt. Just a minute. You open the command prompt and you say IP config. Okay. It will give you the local IP address. Now I'm inside a LAN environment, right? So I'm inside a LAN environment. So this IP that I've received is a LAN IP address of this LAN. If you are trying to access this my computer through this IP address, that will not be possible because there is no physical connection between your PC and my PC, right? So there's no way to access my PC. If somebody wants to access a website remotely, you'll require a public IP address. Public IP address associated with a public server space, a database, and so on. And some time back, I showed you image, right? This one. Not sure if it is visible. Some time back, I showed you this image, right? So this is something that you can purchase. So if you're interested in having or sending data remotely to some server, you can purchase this server space close to $4,000 for 3 years, and you can use that. So you can execute this or whatever code I've done, I put it on the server and try and access it through that machine. Okay, so along with that IP address, you'll also get a domain name. So you can access it through that domain and so on. So it's not that complicated, essentially the same thing, but this IP address would be replaced with some kind of a domain name if you're doing it in a public space. I am inside under a LAN and I'm using it for this thing, right? So that is why this is the case. Now, when you're doing it for LAN, it is all free of cost, no extra cost whatsoever. Okay, no extra cost whatsoever. Okay, and the project that I described, what I'm describing right now, so server, our college server room monitoring system, that is also going to be designed to be on the in the same LAN itself. So there's no issues there. So that is why this is the case. All right. Okay. So I'm setting a delay time of 2000 milliseconds. Okay. Let's. I suppose that would be sufficient. So okay, let me just start by the example that I'm using. So in examples, if you go to ESP32 HTTP somewhere, yes, HTTP client and basic client. Okay. So what I've used here is exactly identical. I just got rid of the extra spaces in between. It's exactly identical. Okay. I got rid of the certificate as it is was commented. Okay, just a minute. I think I'm not the second part. One is not. So if you compare it side by side, it is exactly identical. This is the example code that I picked up from examples. HTTP client and basic HTTP client. This is the example that I've edited. So in this HTTP example, they are using a GET request, right? They're using a GET request. We'll be using a POST request. Okay, so I've modified this program to be able to send a POST request instead of GET one, and I've added a DHT sensor data. So this again comes from examples. There was a DHT sensor library. This one, test, a DHT tester. Share it again. Here we go. This was the tester example. Okay. So essentially the same thing. They go. I got rid of the comments and either change kar diya and that's it. So I have not designed something new or something. I just put together things were already available on the internet. Okay, let me close these two and we'll focus on the code at hand. So we are a bit hard pressed for time. So let me quickly browse through the code. So this part here is corresponding to DHT sensor. This is creating the required variables. And this one here is for making sure that generating delay without using wait or delay. Okay. So that's it. Okay, so let's move on to the setup part. So I've added the these things, Wi-Fi username and IDs, right? I think it would be a good idea to change my Wi-Fi passwords now. So, okay, now we come to the main part, that is the loop one. So this is a most common way of looping through in Arduino without using delay. Okay, so what it does is that it checks the current time, it takes the last time, it is subtract. If it is greater than time delay, it goes in. Once it goes in, it will capture the humidity value. It is going to take the reading, temperature reading, and is going to update the OLED display. So I just showed you right here. So I'm using a small OLED display. This is the Ethernet board, and this is a DHT11 sensor, right? The reason I'm using OLED display is because these are not that cheap, but extremely low power consuming displays. So the OLED display code is on the other tab here, right? So again, sample code, nothing new. Okay. Now comes the HTTP post part. Okay, so once once it is connected, when the connection Wi-Fi connection is established, you're going to create a HTTP client. With that HTTP client, you're going to assign a URL that we saw in the beginning, this exact URL. Okay, then I'm going to specify the content type as URL encoded forms. I could have JSON or plain text, my call. See, in Postman as well, I have the facility to switch to JSON as well as it's down here somewhere. Raw में जाके फिर JSON आता है यहाँ पे. Okay, so I have the facility to do that, but I'll stick to form URL encoded forms. It's my personal preference. So, and then I create a string wherein I'm adding all this data, right? So, ये देखो, whatever data was here, the exact same thing. Okay, this exact same thing is added over here. API key is equal to this key, and then this mode value, sorry, and mode is equal to the mode value. This mode value was obtained over here, assigned over here. So the mode value and location is going to be fixed, right? Mode value and location is going to be fixed. Therefore, I have hard coded it using hash defines. Okay, so whatever is hard coded, if you change the location of it, you can simply just write it in the code. Now, if it were something that I've designed to sell, then I would have added a 4 set of keys to actually key in these values without on the fly. So the client should be able to just click a few keys and change the few values here. The second reason why I love ESP32 is because these are touch enabled keys. So I could use 4 of the touch enabled keys to use an actual keypad, capacitive keypad. Okay. The only thing I don't like about ESP is that it is difficult to protect your code. Okay, there's a very tedious process of doing it. Essentially, if you code this and if you sell it to someone, they could quite easily just extract the code out. Right? It's quite easy. There is a process of encoding the full thing, but it is quite tedious, right? So this is the only downside of ESP. As far as I think, I'm not talking from a compliances point of view. I'm merely talking from a convenience point of view. All right. From a compliances point of view, this is a different headache altogether. Okay. So moving on, I have added the mode name, then the location. Now temperature, whatever value I captured here. Okay, to DHT temperature. So whatever value I captured here, temperature and humidity, I'm sending here. And door status, I'm just sending it as 0. I've not added any sensor for door status here. I suppose we saw a sensor yesterday, like this one, right? So door open sensor. So it is going to detect door open and close. You could use this, or it's your personal choice again. But for this demonstration, I'm simply sending a 0. All right. Once your HTTP request data is created, you simply use HTTP post method. It will reply back with a HTTP code. If it is 200 or 204, means you're successful. But I'm simply checking that if it is greater than 0, means there is some code that is received. If it is 0, means nothing was received and the request did not go through. So I'll just leave it at it. If some HTTP code was received, like 400 or 300 or something, and so on, 404, means I tried, there was some problem on the end of the, from the server side. So I might have typed in the wrong URL and so on. So that is why if it is greater than 100, I'm displaying the temperature and humidity data and also displaying the string. So here, requested string. No, sorry. If it is okay, then I'm displaying the HTTP string, right? Else I'm not. So if I get rid of these two lines of code, I'll be printing every single HTTP request, this thing that is received. Okay. And that's it. This is the only code. So close to 120 lines of code. Mostly quite a few of these are comments, and most of the code is put together from examples. All right. So now let's go ahead and plug this thing in, and let me check if it is able to upload. So in order to simulate temperature change, I may be using a soldering iron. So most of you are electronics engineers and you must be quite familiar. And for simulating humidity, I'll use a moist cotton, right? I'll be using a moist cotton. Okay, that's it. So let's go. I'm going to hold it clearly close. Sure if you are able to. I think it is showing you inverted, right? Try and fix that. Are you able to read this straightforward? Some temperature, right? It's blurred. It's too small, right? So, all right. Okay. So the idea is that whatever is seen here should be updated here. So what I'll do is that I'll lock this up on the left side. And on the right side, I'll have a value here. So all right. So it is sending data and at an extremely high rate. Okay. But if you'll see, this page is quite static. So unless and until I refresh it, I'll not be able to get the newer records. So now there are multiple ways of doing this, but this is the most easiest way. It's not the most optimum, but it is the most easiest way. And the most easiest way is just to add a meta value here, and it is going to ask the server or the browser to refresh this page at let's say regular intervals. So Just a minute. And let's say refresh it every 2 seconds, and have HTTP equivalent as a refresh. Okay, so okay, so there are a few questions in here. There are a few questions in the chat section. I'll answer them at the end of this thing, right? Let me just finish up my demonstration. So what this line of code is going to do is this line of code. This line of code is going to ask the browser to refresh the web page every 2 seconds, right? So let me reload this thing. And now after every 2 seconds, it is going to refresh, right? See? And on the right side, I'll show you the records that are being created. And let me try and hit this now. Okay, so I'm holding it quite close. If you'll see here. So, and you can, I'm not sure if you're able to read these values, but the temperature should be shown as increasing, right? So it's going up to 32, and the same is being reflected here. Now, because I'm on a Wi-Fi and on a Wi-Fi, Wi-Fi is quite high bandwidth, and that's why I'm able to send in this frequently. Ideally, if you're on a lower bandwidth this thing, you're supposed to update the sensor values in once every 10 minutes or 5 minutes at least. We are doing it in a couple of seconds, like I suppose 2 seconds or 3 seconds, something. See, temperatures increased. If I remove this, and the temperature will start dipping again. And let me hold a cotton near to this thing, a moist cotton, and it is going to cause the humidity to rise. You'll see the humidity is rising. Okay, the temperature will slowly decrease and it is going to spike up. Okay, so it spiked till 66. Now I'll just demonstrate how this can be accessed to another device on the LAN, right? So I'm going to use my phone now. Phone will be connected to the, I'll connect it to the local LAN. Okay, and I'll key in the exact URL here. It was the local IP was 192.168.2.66, and the path was ATAL FDP. So I'll show you. I'm not sure if it is visible, but the exact same set and type in the same set of things are uploaded here. So essentially, the requirement is met wherein remote monitoring requirement is met, but it is limited to our college campus only. And in a way, it is a good thing that server room data is not being leaked out of the college. And there is no possible way of accessing this because it is under a LAN environment and there's a firewall that is protecting the entire network. Okay, I'll stop now and I'll start taking questions. We'll take the first question that was there in the chat section. Give me a minute. I'll just close this stuff up, or let it be here as it is. We'll just get the question. So the question was,
Sir, there is one question in the chat box. Can we use RPI in place of Arduino?
okay, by RPI, I suppose you are talking about Raspberry Pi. Raspberry Pi is a very heavy device, right? So if you are, it can be used in place of it. It can be used as a sync node, but that too if you are interested in edge computation. Now this here, what I'm using is a 32-bit controller, and even if I were to use an Arduino, it is still an 8-bit controller, and is more than sufficient information or sufficient compute power. When you're talking about Raspberry Pi, it is huge computation power. So it is equivalent to, let's say, a 4-5-year-old laptop. If you can, of course, do the exact set of things through a Raspberry Pi, but there's no point in doing it because you'll be wasting your computation power. All right. Any other questions?
Yes, participants, any other question?
Can we get these codes from you?
Sure. I'll share it with I'll put it up somewhere and I'll share the GitHub link through
Okay.
the WhatsApp.
Okay, sir.
Okay.
Because we are beginner in this, so at the beginning, at least we'll need some reference.
Sure, most definitely.
So it was very nice session.
Thank you.
Systematically, you went one by one, and it ended with a good results. Thank you.
Thanks a lot. Anything else? If not, then we can wrap up today's.
Sir, any other tools available with respect to your Postman tool?
Come again?
Any other tool available for this function, for this programming?
Of course, there are n number of tools, but the ones that I used are open source and free. So,
okay.
As and when like if you require better capabilities, then of course you can go for purchased IDs and so on.
Okay, sir.
So thanks a lot everyone for attending.
Sir, one question.
Yes, sir.
Sir, if I want to transfer instead of temperature, if I want to transfer image from camera to the destination, so how to do that?
You can send the same image using post would be not a good idea. It would be better if you use some kind of a if you use an FTP protocol instead of HTTP. I suppose that would be a better option. It's quite possible. You can even live stream the video over Wi-Fi, but you will require Wi-Fi at least because it is a huge bandwidth. The video usually consumes a lot of bandwidth, right? So depending upon the video resolution, I would recommend using a Wi-Fi.
Okay.
Wi-Fi environment, and you can actually stream it if you want. Like you can stream it remotely, and you can process it at the sync side. And if you're using that, you can do that with Raspberry Pi. So Raspberry Pi has sufficient compute power to execute an OpenCV program to analyze the video.
Yes, sir. Thank you.
Any other question, participants? Sir, the session was really interesting and lively too. Thank you, sir, for showing this detailed step-by-step demonstration of IoT implementation. It was really knowledge-gaining session. So thank you once again. This is the end. Okay. This is the end of the day. Tomorrow will be the last day for the FDP. So we'll resume this learning journey tomorrow at 10 a.m. Just a gentle reminder to fill the attendance cum feedback form. The link is shared in the chat box.
Thank you, everyone. Yes, recorded sessions. All the videos are live streamed on YouTube. So the link will be provided in the WhatsApp group. Thank you.